ICQ Podcast, episode 327. Transmitter performance with Rob Sherwood, Golf Charlie 0 Bravo. Well, hello and welcome, fellow amateur ham radio enthusiasts, to this, our 237th episode of the ICQ Amateur Ham Radio Podcast. Supported this episode by Gary Bridges, Whiskey Alpha Zero, Victor Mike Victor, along with our monthly and annual subscription donors. In this episode, Martin M1MRB is joined by Leslie, Golf Zero, Charlie India Bravo, Edmund, Mike Zero, Mike November Golf, and Dan, Kilo Bravo 6, November Uniform, to discuss this episode's latest amateur radio news. Myself, Colin M6BOY, rounds up the news in brief, and this episode's feature is a discussion with Rob Sherwood, November Charlie 0 Bravo, on transmitter performance. Well, as always, it's our very kind donors that keep this show advert free for you, and they show their value by doing what they can to help us out. And along with our monthly and subscription donors this episode, we have to thank Gary Bridges, who says he's enjoying the show and wanted to help out. His call sign is Whiskey Alpha Zero, Victor Mike Victor. It's very easy for you to get involved and help us out. You go to icqpodcast.com/donate. As I say, whatever value you find in the show, you pop along to us, send it via PayPal or using a credit card. And as I say, that keeps us advert free and paying our bills here on the internet. Right, well, we're going to proceed on with the show. And we're going to join Martin, Leslie, Edmund and Dan as they discuss the latest amateur radio news, including credit card chip crystal radios and RF noise levels are rising. As always, guys, hope you enjoy.
The ICQ Amateur Ham Radio Podcast, serving the amateur ham radio community fortnightly since 2008.
Well, hi guys, and welcome to this episode of the ICQ Podcast, episode 327, and tonight's news roundtable for that episode. On this episode, I'm joined by Mr. Leslie Butterfield G0CIB. Hi, Leslie.
Good evening, Martin. It's a pleasure to be back on again.
It's great to have you, as always. We've also got Mr. Edmund Spicer, M0MMG. Hi, Edmund.
Hello, Martin. Hello, everybody.
Yeah, been sunning yourself down on the south coast with a lockdown?
Up to a point. There's been more cloud recently, but we've had several weeks of sunny weather, so no complaints.
Yeah, I thought you'd say that. We also got, moving across the pond, we got Mr. Dan Romanchik, KB6NU. Hi, Dan.
Hello, gents.
Good to have you with us, Dan, and as always. And two of the presenters couldn't make it tonight. Matthew's still on lockdown in Spain with his children, so hopefully back soon. Matthew is call sign M0NJX. And unfortunately, Ruth, KM4LAO, couldn't make it tonight because this week is finals week. So, Ruth, Ruth, we wish you every success. But I'm sure you'll do well because you've been working hard on this for the last few years on this one. So best of luck there, Ruth, with your finals this week. Okay, moving on to our first news story. Not a lot news, but hopefully some things that will make you smile. Credit card chip used to make a crystal radio. Really? Go on, Leslie, tell us all about it.
No, credit cards are meant to be used for buying radios on eBay, not for mullering up and crystal. Anyway, I digress slightly. No, it's from a site called Hackaday, which has got lots and lots of projects. It's brilliant for the radio amateurs. But anyway, this particular project, it's a variable inductor medium wave radio, and it's got like a rotating variable inductor on it, and it uses the SIM card as a diode, and then that's fed to some headphones. It does work, believe it or not. It does work, and it's a fun project. What can I say? I did mention as well, there's a video, about a 45-minute video, but you can get the idea on how it works pretty quickly. Like I said, it's a fun project. Feel free, people.
Yeah, and often we get these old credit cards or bank cards. There's something you can use it for. Dan, would you blog about this, or have you seen it?
I have seen it. I haven't blogged about it yet, but I do love the construction of that coil. That coil was really nicely done, don't you think?
I think it was a work of art. And,
Yeah, it's beautiful.
And at least it's something different. And I could joke and say, well, we're all on lockdown and got too much time on our hands. These sort of things happen. But it's somebody thinking outside the box, I think.
Yep, absolutely.
Yeah, so that's a good one. Now, Edmund, you tell me, you've not had a lot of luck with crystal sets, have you?
I have a love-hate relationship with crystal radios. I have never managed to build a kit that has worked successfully. When I was a teenager, my parents gave me a crystal radio kit, and I remember making a right mess of trying to wind the coil neatly, and it never worked properly. And in the years since then, I've bought a few more kits, mainly for a pound a time at car boot sales, and I've never been able to get any of those to work satisfactorily well, shall we say. So I do have a rather love-hate relationship with crystal sets. They're out to get me, I think. So I won't be attempting to make one of these, and I certainly wouldn't try to make one on any of my current cards that I might have. There's a good 10 plus miles from here to the nearest medium wave transmitter. So, given the size of this thing, I kind of wonder if there would be enough RF floating about to drive a credit card sized crystal radio. But it's a wonderful. I mean, how on earth did the person come up with the idea? That would never have occurred to me in a million years to do something like that. So, good on him. And if I get really, really, really bored, I suppose I could try it and then walk 10 miles to the local medium wave transmitter and see if I can pick anything up while standing underneath it or that kind of thing. But yes, it's good fun, isn't it? So it did make me smile, despite how I feel about crystal radios in general. Back to you, Martin.
Yeah. Well, I'm glad you enjoyed it. In fairness, when we do our intermediate course, you have to, as part of your practicals, build something radio related. And we build a little AM medium wave receiver. Now, it works quite well. They have to wind so many turns on a ferrite rod, and I have a remembrance of somewhere around about 55 turns. However, in fairness, just down the road from the Scout Hall is a big Christian radio station on AM pumping out, I think, megawatts. So it don't really matter whether you wind a coil correctly or not. You always receive Christian radio. In fact, Neil, one of the other instructors, once unwound every turn off this ferrite and just had a big loop, and it still received Christian radio. But it's a little more on the crystal set. This particular one, yes, it has got an IC in it. I think it's a LM414, the little three-legged chip that looks like a transistor, little tune radio receiver, and an audio amp with it. And yeah, they're fun to play with, but with the background noise now and without a massive aerial, I suppose crystal sets, their days are really numbered in today's modern society, the amount of background noise, I suggest.
Well, the ironic thing, Martin, is that for my intermediate in 2010, I built an FM broadcast receiver kit, and I still listen to that, and that works to this day, and it worked first time. It worked first time, no problem at all. It's just, I don't know what it is about crystal sets, Leslie, but they don't like me. They're out to get me.
It's a cat whisker was winding you up. That's what it is.
Well, I tell you what, Edmund, I'll admit it too. I've always had problems with crystal sets. I don't think I've really ever gotten one successfully to work.
Oh, thank goodness I've heard somebody else say that. I'm so glad it's not just me then.
And I've tried a couple of times too.
You can actually make a crystal set out of a razor blade and a bit of a pencil lead.
Yeah, that's what they say.
Yeah, no, you can do it. It's
I've seen the plans.
It was about 40 years ago I built something like that.
Well, I haven't shaved for like 40 years, so I don't even have any razor blades.
How did you get away with that, Dan? Mrs. B won't let me grow a beard.
I think that's one reason my wife married me, because I had a beard.
There you go. So horses for courses, and it has to be right. But no, I think with the crystal sets, I think where a lot of people go wrong is they don't have a good earth and they don't have a sufficient aerial out. And you've got to have a fairly resonant or enough wire out to pick up enough signal, because bearing in mind, if you're using a little germanium diode, it's got to be at least 0.2 of a volt a signal to turn that diode on. So you've got to receive a lot.
Long as possible, about 130 feet if you can do it.
Yeah. So, a little bit of fun. I kind of like this one, and we've all had a bit of a giggle about it, but what a good one. Next news story. Well, not quite so fun, because I've noticed this being a problem, but the raising of the RF noise levels. The IARU submit papers to the CISPR. Now, what a lot of acronym there. We know what the IARU is, but let's see if they can do something about these noise problems. Dan, what's your thoughts?
Well, that's really the question: is what can actually be done about it? And I'm not all that hopeful, actually. Thrust of the paper is that the number of electronic devices has just exploded recently. And they even say, well, think about your own situation. How many more electronic gadgets do you have now than you did, say, even 10 years ago? And each of those is a potential noise source. And so, I don't know what the solution is. And on top of that, everybody wants cheap, right? They don't want to pay a lot. Well, to design stuff that doesn't emit interference, doesn't emit electromagnetic radiation, you got to pay for it. So, I honestly, I'm not that hopeful about it.
No, I agree where you come from, and I've certainly noticed noise starting to creep up into the VHF part of the spectrum. And there's a lot of noise down on the HF part, but it's starting to creep up there. Leslie, you any thoughts on this one?
Oh, what can one say? Yeah, I did look at this. That there's a what actually CISPR actually stands for. There's a French version, but the English version is, if you don't mind, I'll use that one. It says the International Special Committee on Radio Interference. And I've gone through, there's a lot of papers they've produced on things like scientific instruments, vehicles, boats, electrical tools. There's a whole rake of stuff that they've produced. And Dan is quite correct. I mean, the difficulty is that market forces, there's a demand for all these products. And some of the manufacturers, they do cut corners on the filtering. I remember some PCB boards had it was reported had the filtering components removed. So I think this report is a start, and it's a case of, well, okay, this is where we're starting from. How can that be put into some form of action to actually, should we say, persuade? I prefer to persuade manufacturers to sort of clean up their act a bit. And that's where we are at the moment, I think. But it's the market demand for products is huge, absolutely huge.
Yeah, and everything electronic's got an oscillator in it, so therefore it's radiating.
Well, here's one thing. Let me just jump in there. So one thing that we didn't have really much of 10 years ago is LED lighting. And this paper points specifically to LED lighting as a big major source of interference.
I agreed. I mean, if you look at LED lighting, it can be the lighting itself is actually very, very efficient. I forget the figures, but an 8-watt LED is very, very bright indeed. The problem comes with the power supply,
Right.
and that, to be honest, some of them are just awful. They're dreadful designs. So
Right.
that's really where the problem lies at the moment.
Yeah, it's interesting. Edmund, what's your thoughts on this one? You got lots of noise problems?
Increasingly so. I used to be very lucky, and I'm very mindful and thankful that I had the luxury of being lucky, that in my location, which is semi-rural, shall we say, I'm not in the middle of open countryside, but equally I'm nowhere near in the middle of a town centre either. The noise levels traditionally used to be quite low. 40 metres is my band of choice. It's the one I have an inverted V dipole for, stretching diagonally across the garden. At various times of the day, I can have anywhere between S2 and S9 of noise on that band. The worst it ever used to be before lockdown was about S6. So during lockdown in particular, more people are using more devices more often, or might have been out spending their furlough money on buying new devices with these noisy switch mode power supplies connected to them. And it's really a case of you take your chance and sort of go on air to try and make contacts whenever whoever it is doesn't have whatever it is switched on, but it's a cumulative effect. So I kind of agree with Dan. I think the horse has bolted on this one, because even if from tomorrow all electronics passed these emission standards with flying colours, we've still got all the stuff that's out there already. And even if I had bucket loads of ferrite cores and things that you could attach to equipment to stop them radiating, because there are so many devices involved in so many places that are only switched on for some of the time. If I had to go out and try and DF every single item in everybody else's house, that I could then try to suppress this interference, I wouldn't know where to start, and it would take forever. So scale that up, not just little old me here in my particular location, but scale that up onto a county or a countrywide level. And I just don't know where you would start or how you would go about starting, to be honest. So sorry to sound pessimistic, but I think Dan and Leslie have got it spot on there. Martin, back to you.
Yeah, well, if I was being very naughty, Edmund, I'd say get a big metal bar, go down to your substation and throw it over the top and create a... Yeah, go on, Leslie.
Martin, you could use these the PLT devices as a sort of a clay pigeon substitute. Over.
I think you could use them as a clay pigeon substitute. No, I was thinking of more of creating a power blackout and then running your radio on the batteries. Wouldn't have any noise then, but we'd be in trouble for that, wouldn't we?
Yeah, I'm being naughty. Give myself a slap.
Oh, no, we're all being naughty. But I remember going back about 10 years or so, I was working nights, permanent nights, and I had a funeral to go to. I think it was on the Wednesday. So I didn't want to change my sleep pattern to go for the funeral on the Wednesday. So I effectively stayed up all night, went to the funeral, come back, went to bed like I would normally do. And I was playing radio that night, and it was quite interesting. One of the things I was doing was APRS. And at that point in time, up until about midnight, there wasn't many digi-repeaters I was hearing, and not a lot was happening. And pretty much after midnight, the whole VHF spectrum got a lot quieter. The noise level dropped till about 6 in the morning. And it was quite strange. I could track vehicles all over Europe quite happily through, obviously, digi-repeaters. But at 6 o'clock, bang, it came back. And, there's a lot But there was one thing I did read the other day, and hopefully I've got it right. ARRL 1966 handbook, and it was talking about an SWR power meter showing forward and reverse power. And the guy said you may also get some harmonics generated off the diode used for rectification for the meter movement. And I'm thinking, I would have never have thought that a diode would have created harmonics and that. Now, I could be wrong. It could be a typo. But that made me think.
That's actually true, because if you look at designs of noise bridges, that's what they have as their noise source.
Yeah. So little things like that, and you suddenly go, well, I didn't pick that one up. So, we could be creating our own interference by having an inline power meter, for argument's sake, in your circuit. So, and it suggests you put a low-pass filter after this meter. But hey hum, just another little thing, gone off at a tangent there. But
as we do.
As we do, yeah. And I'm glad you confirmed I wasn't totally losing it, Leslie. Okay, right. Next news story. And the boys said I might be talking to myself on this one.
No, on this one, Martin, I've just looked at the next subject, so I know nothing about this. Can you tell me more?
I can, mate. AO73 is now in full-time transponder mode. Now, AO73, I believe, was FUNcube 1 satellite. It was the first FUNcube that was used with the FUNcube dongle. It was prime use was for education purposes for schools and one thing or another. And when it's not being used for that, it switches into an amateur radio transponder. Now, I find it fun because a few Christmases ago, I got bought a FUNcube dongle. And yeah, all right, I did the usual thing of listening to broadcast radio with it and listening to amateurs and one thing or another, and it works very, very well. But one of the nice things about this is if you look at what the schools are using it for, you can actually go along and download the telemetry when the spacecraft comes over. And they also, if you were, say, school XYZ that was talking about it on Friday, you can get messages uploaded from the ground station so that when the satellite comes over, the satellite sends you a message to your school of students, which to me is really good because it really engages kids. So, with that in mind, I hadn't used it for a long time. I took a laptop, my FUNcube dongle, and a little mag mount, stuck it on the van roof the other day, PC in the back of the van, and was showing people at work a satellite as it went over, and worked very well. So that's what it's about, Leslie. What do you think?
I think this sounds really, really interesting, Martin. Like I said, I've not been involved in that side of things myself, but I'd like to learn from other people what they're involved in. And it's anything to do with education, and it's how we can show people what we do in the hobby. That's important.
Yeah. Well, I'd say it's not everybody's done this, and you could look at it and go, well, why would I bother? But it's just something else you can do sometimes. Edmund, I take it you haven't really played up at this level.
No, I'm afraid not. I don't own a FUNcube dongle. I've never used the software, and to the best of my knowledge, I've never received AO73, so I'm afraid I can't wax lyrical about it, Martin.
No, it's no problems. I mean, the FUNcube dongle at the time was about £145. I don't know if they've gone down in price now. But there are certainly more useful SDR dongle type devices now. But I think the thing that really sets this one apart is the software for being able to download the data. And if you want to, you can download and store it off to the data warehouse, where anybody who's doing analysis on this can actually see what's going on all the time or over a long period of time with it. So that's useful. Dan, have you looked at anything like this?
Well, honestly, I have not either. But my question was, when did they first send this up?
I got a feeling, Dan, and I should have looked this one up. I got a feeling it was about 2013, but around maybe a bit earlier than that, but round about then. So it's been up a while.
Yeah, okay.
There are some other ones up there now. I think AO 91 and 92 are also CubeSats that can do very similar things, but this one was the first CubeSat to be used the FUNcube dongle software.
I see. Well, good. The next item here is also about FUNcube, and I have some comment about that. So I'll hold off till then.
All right. Well, we'll move on to the next one because I probably threw you all a curveball because I got quite excited when I saw this, and
That's fine, Martin. We'll forgive you.
yeah. Well, I went out playing, didn't I? So I can't help it.
It's what we
Anyway.
do. It's what we do.
Yeah. True. Anyway, next news story is that Raspberry Pi FUNcube satellite telemetry decoding is now available. Now, a Raspberry Pi costs very little money. If you've got a Raspberry Pi kicking around as I have, and you've got a FUNcube dongle, then you could pretty much have this running all the time, uploading information to the data warehouse, and be monitoring a satellite for the fun of it. I think Raspberry Pis are now cheap enough that they're almost becoming appliance devices. I certainly run one with a DMR hat on top of it, which is on all the time. But Dan, you go first on this one.
Yeah, so I kind of keyed in on this because I had come across another Raspberry Pi ham radio project, and I'm thinking, well, geez, now if I do this and start to receive the telemetry and also implement the other project, which is an implementation of a ham clock using a Raspberry Pi. It's one of those fancy things that shows the gray line and gets information about the solar flux and all that kind of stuff from different places. I said, and I have a sort of a spare monitor. I could, put all this stuff together for, less than $50. That sounds like a pretty cool thing to me.
Yeah, well, you probably, if you get it working, Dan, you probably won't need a monitor because once you've got it up and working, it becomes pretty much an appliance, and you can remote session in with either something like VNC, and take control as a remote session. So, you can sit with your PC at any time and say, right, I'll remote onto it, and it'll be there.
No, that's an interesting thought too. I didn't think about that.
Yeah, so that's just a thought. Now, Edmund, I know I've got you outside your comfort zone. I know you think the computers are the work of the devil, but any thoughts on this one?
Well, I wouldn't put it quite like that. I don't think they're the work of the devil. I just am not particularly up on computers and computer programming. In the 1980s I was, but unfortunately as technology moved on I never kept pace with it. So I still don't own a Raspberry Pi. I'm sure the day will come eventually that I buy one from somewhere. But as things stand, I don't know enough about this subject to say anything sensible, I'm afraid, Martin.
Well, no problems. I always give you a little bit of a hard time over computers, but we don't mean to, Edmund. We love you dearly, honest. So, yeah, they are turning in now. They can either be used, they were originally for education market, but they're quite cheap enough now that they could be set up for all sorts of monitoring devices that will pretty much just act as an appliance. As I say, my one running the DMR software, I don't think it's been switched off in about 6 months, and it rattles away quite happily. So, but it costs very little to run as well. Leslie, your thoughts on this one?
Gosh, I mean, I remember, please don't laugh at this, but I remember using a BBC computer, building that, and what was the other thing we used? There was a Spectrum computer in which I run on a RTTY program at the time. That was so long ago. And when I look at this stuff now, it's absolutely fantastic. I mean, I just get projects popping up that what these Raspberry Pis can do, and it's absolutely phenomenal for the price and for the adaptability for the radio amateur and the things you can do with it. I mean, it's absolutely fantastic. It's out of this world.
Yeah, well, I won't knock you for the Spectrum, because Colin, when he was much, much, much younger, thought I was a total type person for not buying him a Spectrum. And why did we have to have this IBM PC, Dad? And then, then the penny suddenly dropped when he got Football Manager for the PC, and it was like 500 times better than some of the other PCs. But yeah, I used to, being an engineer on the road at the time, I always used to have a machine in the back of the car, and at weekends, you know, you weren't supposed to leave stuff in the back of your car unless it got broken into.
I just remembered when I mentioned the BBC computer, I had a dinosaur walk past out the rooms.
Hey, don't you knock it. I've still got 2 Apple IIs in the bottom of my junk room that I really ought to do something with. I got software, the floppy drives, the whole 9 yards.
And the extra memory chips you had to plug in.
Hey, you used to start off with an Apple II the original Apple II Euro had 48k of RAM, and then they had a language card that put you up to 64k of RAM.
I'm showing my age now, I really am.
You are, but so am I, mate. I worked there. I was there.
What can I say, you know?
Yeah. But anyway, we digressed again. But nice little device.
It doesn't matter.
No, it's true. It's true. We get away with it, Leslie. Right, last news story. And I'll be honest, I ripped this straight off Dan's website, and because I thought it was a good news story. Collins are driving another nail into the amateur radio Emcomm coffin. So, Dan, I think since you put this one up, we're going to have to go with you first on this one.
Well, that's fine.
But we were quite a bit of discussion on this one earlier.
Dan, I can see you now gashing at the bit. Go ahead.
we say gnashing at the bit here, but anyway. So the story here is that FEMA, the Federal Emergency Management Administration, has bought into the Collins Aerospace Urgent Link system. And apparently, according to some of the responders on my blog, this system has been around for a while, but only now has FEMA decided to go with it. And the story here is that they will start using the system. And Urgent Link, what it is an HF emergency communications system, and it uses HF radios in a big sort of mesh network configuration to provide emergency communications wherever it's needed. They're going to put stations in 6 of the FEMA branch offices, 6 regional mobile emergency response support locations, they say in the press release. And they have 100 other radios that can be deployed wherever they're needed, apparently. So the thing that got me was in a 2018 brochure that describes this system, they say ham radio operators provide a very important service during and after a disaster using high frequency radios, blah, blah, blah. It says there is a weakness, availability. Ham radios require a skilled and experienced operator. The greatest need for them is typically during the first 24 to 48 hours after a disaster, and it's during this time that it's most challenging for people to get around. So, I mean, they're really kind of putting the knock on ham radio here. Whether or not that's warranted is another matter. But I just found it pretty ironic that Collins would be the one putting the knock on ham radio operators. So anyway, this is kind of an interesting system, and like I said, could be another nail in ham radio's Emcomm coffin.
Yeah, it could be, and I think we need to monitor this. Edmund, you got any thoughts on this one?
I'm afraid I haven't, Martin. Sorry.
Well, it's HF, isn't it? And it's very similar to our RayNet, what they're trying to do, but make it more commercial. So I'll pass it over to Leslie. Leslie.
Well, I was looking at this, and I can only go by the blurb that I've read, and it, as Dan said, it's like a cell network system where once you've got into the network, you're in, and that's it. I was working on a similar system about 30 years ago, and without going into the details of what the system was, basically the operator had a box underneath there where their feet was, and they had a keyboard in front of them. So the operator didn't know how to know about antennas because there was just one. They had to just put the one antenna up. They didn't know how to, didn't have to know how to tune the radio because it was completely automatic. Didn't have to understand about the link, how to link up because that was automatic. All the operator had to do was basically just operate the keyboard. And it threw the skills, it did temporary, it threw the skills that we normally have as radio amateurs. It made those redundant at the time. The problem is that the radio amateurs have a huge advantage is that when something happens, we can set something up ad hoc. We can plug it into the vehicle, into the cigarette lighter socket, and we can have a system up. Let's say within 20 minutes, half an hour, and we can have a basic HF system up. In disasters, structures and commercial setups tend to be really shaken to the core, and it takes them a while to come back online. So is this going to get rid of our radio amateurs? No, I don't think so. I don't think so at all. Yes, it's what commercial people do. They try and make it a lot easier for the operator. And let's just see where this goes, Perhaps we can pick up some of the things they're doing and they'll be adapted into HF radio. But things have got to progress, and I'm not going to get out of bed about it. They these things happen, and we march on, as they say.
Yeah. Well, I kind of agree with you because this was my biggest argument was if you can have all these systems, anything system you like, but if a tornado goes through your village and you've got one of these systems in your village, chances are it ain't going to be standing when the tornado's gone through. Because I've seen some of the devastation that does happen in the States, some of the videos and the pictures, and it's quite frightening.
Oh, it's absolutely devastating.
Yeah. So that's where your amateur, we turn up with a bit of wire and a fishing pole and a HF radio and a battery, and we're on the air within half an hour max. So that's where we went out. The other thing I will say is, not just natural disasters, 9/11. Where was all the comms for 9/11 in New York? The comms went,
yeah.
That was all on top of that building. And I still feel very sad about the people who lost their life in it. But if it wasn't for amateurs who got the temporary systems in quick, the whole of the emergency services lost their repeaters overnight. In a matter of a few minutes.
Well, that was just poor system design, relying on the emergency communication systems on the very building that was destroyed. There should have been
redundancy in the system,
and actually that's what this has, because they're operating a network of stations across the country, and if one goes out, another one, presumably you make contact with another one, and you're off and running again.
Then you're into the once you're into the cell, you're into the network.
Yeah. So it's this kind of an interesting thing, and also this a little different than the World Trade Center thing, because that's kind of a local situation. This is more of a national or wider area situation. That's where this system would come in. So it's interesting to see all the replies on my website. I got a lot more replies than I thought, and about half of them say, "Oh yeah, Emcomm's dead," and the other half say, "Well, no." And then they bring up all kinds of cases where ham radio is still playing a big part in emergency communications. So it's interesting to contrast the two different types of replies there. So if you're at all interested in it, I usually don't push my blog on this podcast, but it is interesting to read. This one is really interesting to read.
I think it's a case of just wait and see what happens.
Right, I agree with that too.
Well, it was interesting. It's an interesting discussion point, Dan, and I'm glad you didn't mind me stealing this one directly from your website.
Well, I stole it from Southgate, so
all right,
no worries there.
All right. So I'll blame you on this one. No problems. Well, as I say, I think it's an interesting discussion point. As Dan said, there's a lot of things on Dan's website talking about this. Dan's website, from memory, is kb6nu.com, unless I'm wrong, Dan?
You're absolutely right.
Yeah, I thought I was, because I went there fairly recently. But no, check Dan's website out. He puts a lot of interesting stuff up on there as well. Okay, well, that concludes our news stories. A little bit of a fun one, not too strong, because I think because we're all in lockdown, a lot of things are not happening, and I don't really want to keep giving you doom and gloom stories, so we try to pick a few light-hearted ones. Okay, let's find out what the guys have been up to. You're going to put me to shame this time, but okay. Leslie, you go first on this one.
Right. What have I been? Well, actually, I've still been working. So anyway, apart from that, whoops, as you probably hear in the background, I'm just getting I've been playing with a new radio, and it's called a Lexion VV898SP, which I purchased from a well-known emporium, and it's like a transportable VHF, UHF FM set with its own battery in. It can do up to 25 watts. Not sure how long the battery's going to last on 25 watts, but I think it's either 25 or 10. I may need to be corrected on that. But I've been playing with that, and I'm very, very pleased with it indeed. It certainly does the job. And I've just been, like I said, I've just been pottering about with that at the moment. And another one, I didn't say this to Martin, but I've had another book come in my post, and it's called Understanding Radio Book 1 by a guy called Anthony Naylor. Very, very interesting. It says for the radio amateurs, listeners and constructors. And it's all sorts of interesting stuff. So I've been working through that at the moment. When you sort of, well, how does that work, And it's one of those types of books. So I'm going to be a bit busy with that one at the moment. Back to you, Martin.
Yeah, it sounds interesting, Leslie. And I'm going to put you on the spot now. Really am.
Oh, go on.
It'd be interesting once you've read your book and played with your radio a bit. Why don't you knock me together a few minutes of audio just to tell the listeners what your personal thoughts on these products are? Yeah, if you've got time, that is.
Of course, I'll do that for you, Martin. No worries at all.
Magic. I think it's nice because when we've got new products and we tell people about it, one of the things I do get when we go rallies is people come up to me and they say, "You know what you told us about that book, or this book's a good one, or this piece of kit's a good one. I bought it and it really is." So it does improve our credibility as well in many ways. But that's good, Leslie.
Martin, I will do that. No worries at all.
That's great. No problems. Edmund, have you been playing?
Not a huge amount because, like Leslie, I'm still working. But I'm pleased to report that for the first time ever, I worked the States on 40 metres. Only ever done it on 20 metres before. And it was very late at night by my standards. I tend to be a morning person. So I don't do staying up to the wee small hours very well. But a couple of weekends back, I did stay up very late for some reason or other. I can't really remember why. And I turned the radio on at gone midnight, and there was a station Whiskey Alpha 3 Romeo Sierra Lima, that's Frank, and he was about 5 and 7 to me, so we actually had a proper little QSO, not just a 5.9 rubber stamp. Really interesting setup he's got, wire beams on 40 metres. So, okay, his end was doing all the work, but he wouldn't have been able to work me if I hadn't been there. So, very pleased about that, because until then, I'd only ever worked America on 20 metres. And that's the only band, I think, if memory serves me correctly. And we were talking earlier in this podcast about noise. If that had been 2-3 hours earlier, even if he'd been at the same signal strength with all the hash from, I don't know, flat screen TVs and electric car charging points, the neighbours have had one of those put in, and LED lighting and goodness knows what else all combined together, I honestly don't think I would have heard him. So maybe that's the answer. Perhaps I need to turn into a night owl. The only other thing worth mentioning is that the International Museums Weekend takes place on the 3rd and 4th weekends of June. So that's the weekend that the podcast is being released and the following one. And I think the following one coincides with the ARRL Field Day, doesn't it? So maybe I'll go transatlantic then as well. I don't know. So during those 4 days, I'll be on the air as much as possible, pretty much everywhere from 80 metres to 70 centimetres, using the club call sign Golf X-Ray 3 Whiskey Mike Uniform in support of Amberley Museum in West Sussex, which is still closed to the public and volunteers, and is likely to remain so for quite a few weeks, if not months, to come. So if you hear this podcast in time, please do listen out for GX3WMU. Most of the excitement will probably be on 40 and 20 metres, but if sporadic is kind to me, I will try the higher bands as well. And I'm even getting my 3-element 6-metre Yagi, pulled that out from the weeds at the bottom of the garden where it's been standing for far too long, and doing a bit of a restoration job on it, although the elements are a bit bent and wonky and I've had to sellotape one of them back together. So probably doesn't work that well for a 6-metre beam, but you never know. So if you're around those 2 weekends, then it would be really nice to work you. But apart from that, Martin, I can't think of anything else, and I certainly haven't been trying to build crystal radios.
Yeah, well, that's good, Edmund. And I'll be down your part of the world round about lunchtime on Sunday, I believe. It could actually be Saturday, but it's looking like it's Sunday. And I don't think I've worked you on 4, so I may have 4 meters FM in the car. So on the south coast, 4 meters FM might be a little bit lively, guys. If you hear Edmund working me, give us a shout. So that'll be good.
There's certainly quite a lot of operators on the West Sussex coastal strip between, say, Chichester to the west and Brighton to the east, who monitor 70.450. So if you are passing through, even if you don't hear anybody, if you put a shout out on that frequency, which is the FM calling frequency for 4 meters, you stand a reasonably good chance of having somebody come up and talk to you.
Well, let's hope Mrs. B doesn't get too upset at me working radio instead of not talking to her. But yeah, no problems, so that'll be good. Dan, what have you been up to?
Oh, all kinds of things here. One of the maybe more interesting things is last 2 weeks, I've been teaching an online technician class. So I got an email from a guy about 3 weeks ago. He says, hey, I live in Portland, and I got a group here that's interested in taking a class. Nobody's offering classes here. Would you consider doing an online class? So I said, yeah, the only problem I can see is how are they going to get tested? Well, he contacted the W5YI group and said, and they agreed to do a group remote test session. So the last, instead of teaching it in one day like I usually do, I said, well, let's do 4 2-hour sessions. And we've been through 3 of them, and then the last one is tomorrow, Thursday. And right after the class, they're going to sign into the W5YI website, or the guy's got a separate website set up, I think. But then they're going to take the test online. So I thought that was pretty interesting.
Excellent.
Yeah. So and there's been quite a bit of interest in it. So I can see doing this again next month, and maybe every month for the foreseeable future. So we'll see about that. Another thing, we all talked about field day, field day was just mentioned here. So of course our club isn't going to do the big club field day like as we usually do. So that's gotten us all starting to think about what we can do on our own. And what I think I'm going to do here is operate off a battery. I have a KX3. I'll operate QRP off a battery, and that gives me bonus points to operate QRP off a battery. And see how that all works out. I think I should do pretty well on doing that. So I've been preparing for that. Make sure I even bought a solar panel. So I'm going to solar charge the batteries, and I get a few more points for that. And that's what I've been up to. And for field day is less than 2 weeks away, so should be fun.
Yeah. Well, I might be giving secrets away, so I'll apologise to Rob Sherwood in advance. I was talking to Rob Sherwood last night, and he's going to be operating from his back garden, battery power as well, Dan. So you might be up against Rob. Hi.
Well, I don't know. I'm always up for a challenge.
Yeah, no probs. Okay, what have I been up to? Well, probably not very much, apart from I have been watching Dan's videos. Dan has been very quiet on this one, but he's put out some interesting videos up on YouTube that I know has taken him an absolute age, and they're very, very interesting. So go on, Dan, just a little bit about those. Plug yourself.
Okay. So what I've done is I've taken my general class study guide, and I've started to chunk it into chunks, break it down into smaller chunks, and make 8 to 10 minute videos on different topics. So the first one I did was on decibels, so I covered the questions on decibels. The last one I did yesterday was on vacuum tubes and batteries, covers the questions on vacuum tubes and batteries. And talking about how long it's taken, that video is about 4 minutes long. And it took me about 4 hours to actually produce it. So these things take a long time.
I'm sorry.
They take a long time. But they've been amusing, and I'll probably continue to do it, see if I can work through the whole general class study guide.
Yeah. I mean, I found them enjoyable, Dan, even though I don't have to do it now, because I did mine a few years ago. And in fairness, I probably think I did my American exams before I knew you, so I didn't use your study guides. Although I have seen them since, and I do think they're very, very good, Dan. So that's
thanks.
Would have certainly helped me.
They're on. By the way, if in case anybody else wants to watch them, they're on my YouTube channel. So you can go to YouTube and search for KB6NU, and you'll find my YouTube channel.
Yeah. Right. Well, as I mentioned earlier, I had a play with AO73, used G-Predict to predict when it was going to come into range, showed the guys at work. That was quite successful. I've been mainly doing VHF work and playing with my Arduino. And I've got myself into a right tiz because Mr. Popey's book, the original one, and he gives you all the source code and everything. I had something working. I had the weather station working, and I took it apart, and I had to use the Arduino for something else. Then I wanted to put it back together, and the program won't compile now, and it's really doing my head in. But I'm really going to have to work that one out. So I've been doing a fair bit on Arduino. I also mentioned many times, and probably bored most people to death on this, I also renovated a Hacker Mayflower 2 VHF FM broadcast radio And instead of just doing a video of this is Martin sitting here changing capacitors and resistors and measuring this and measuring that, I did a few short slides showing the quality of the radio, the finished item. There's a couple of text slides telling you what I did. And then there's a very short video showing the radio with the sound quality. And it runs for about 3 minutes, but for anybody who was wondering what I was on about, it's up on the ICQ channel on YouTube/ICQ, and it only runs for about 3 minutes. So it was a little bit of fun to do that. So that's what I've been up to. Not as much as you guys, but I'm still enjoying the radio. Okay, so I'd like to thank each and every one of you for joining me tonight. I'd like to thank Mr. Leslie Butterfield G0CIB.
Thanks for inviting me, Martin. It's been a blast.
Yeah, it's good to have you. I'd like to thank Mr. Edmund Spicer, M0MMG.
Thanks for having me on, Martin 73.
Yeah, great to have you, Edmund. And Mr. Dan Romanchik, KB6NU.
Well, thanks. Thanks for plugging my videos. Thanks for letting me rant a little bit. I love these podcasts.
They're fun and we enjoy ourselves. And I think a lot of the listeners do say to me, you guys have too much fun. And I go, you can never have too much fun. So,
No.
Can I just say one thing, Martin?
Go on, is it rude?
I know. I'd like to thank the listeners for their very, very generous donations, because I don't get much from radio amateurs, but I have been issued with a new microphone. So I'd like to thank everybody that sent in donations. Cheers, it's appreciated.
Yeah, well, we're slowly replacing hardware for people. So a number of the presenters which have got poor hardware will get new bits and pieces fairly soon. We get a few donations. We don't make an absolute fortune out of it, but we do feed back your donations into producing this show. And that's one of the things we do. We changed our recording software. We're changing some of the microphones out in the field, and all sorts of things like that. And the other thing that really shows us off is the orange shirts when we do events. I remember going to a rally earlier this year, and the organizer turned around to me and he said, the professional broadcasting company that turned up looked like a pair of tramps. He said, but you guys were turned out. A good corporate turnout. You're recognisable and smart. That's all thanks to the listeners. So anyway, I shouldn't get off. I'll get off my soapbox. Yeah. Right, guys. I'll say 73 cents. 73.
Cheerio.
73.
Yeah, and we'll move on with the next part of the podcast.
And now it's time to have a look at the news in brief from me, Colin M6BOY. Thanks to Steve Hartley here, Golf Zero Foxtrot Uniform Whiskey dropped us some mail in relation to the G-QRP convention that was due to take place in early September this year. Now, obviously, due to the COVID restrictions, etc., they had to cancel the event, but some good news because they sent out a survey to members and the general amateur public, and you may remember we mentioned this on the show recently. And following on from this and this successful survey, they've decided to make the G-QRP convention for this year a virtual event over the weekend of the 5th and 6th September. So there'll be a series of webinars, possibly a virtual build-a-thon, and a small working group where they're developing details, and a number of key speakers have already volunteered. And they'll be letting us know about further details as when it becomes available. So good news that this convention will be going ahead in some form this year. Keeping on the theme of conventions, news here from Hamvention. They're obviously we lost Hamvention this year, but doesn't stop them working on the 2021 show. So they've announced a new general chair, which is Rick Olnott, Whiskey Sierra 8 Golf. Rick's been a licensed ham since 1982 and holds an extra class license. He's been involved as a volunteer for the last decade on the show. His passions are as a CW operator and an occasional contester. Now they've also announced a new assistant general chair, and that's Jim Storms, Alpha Bravo 8 Yankee Kilo. Again, an extra class licensee holder He's currently an ARRL VE team leader. Has served as a past president, vice president, and secretary of the SWODXA club, and he served DARA for the last 2 years as vice president. So certainly comes with a lot of expertise as well. The Dayton board are grateful to Jack Gerbs, Whiskey Bravo 8 Sierra Charlie Tango, for his recent service and in his leadership of nearly over 750 volunteers to get this event on. So the guys take over their new roles from the 1st of July, and of course we at the Amateur Ham Radio podcast here wish the guys the great success in what they're doing now. Now here's I suppose a long-running dispute that's been going on in the world between Russia and Ukraine, and you probably remember the Crimean annexation by Russia. Got to be careful, I suppose, how you promote that one. But there's been a radio war been ongoing for quite some time, and it's been working on 7055 kilohertz on lower sideband. Now, this is starting to escalate, and they're even now starting to see effects at 7050 and 7060 kilohertz, and even now starting to also affect 1700 kilohertz as well. Now, obviously, where this is a worry for us is at 7080 kilohertz, which is the entire FT8 traffic on 7074 kilohertz that would be heavily affected, particularly around the Eastern European region. So it's something to keep an eye out for here, as say this escalation of whatever propaganda they're messing around on between the two countries here could start to affect the FT8 traffic around that area. So certainly something to listen out for in relation to FT8 traffic through Central Europe. Right, well, now we head on to our features episode, and our feature is a feature with Rob Sherwood, November Charlie 0 Bravo, and Rob is discussing transmitter performance. As always, guys, hope you enjoy.
Keep your amateur ham radio podcast advert free by donating less than a length of coax. Visit www.icqpodcast.com/donate now. For all the news, links and information, visit www.icqpodcast.com.
And now what you've all been waiting for, this episode's feature from the ICQ podcast. Hi guys, for this episode's podcast I've managed to obtain the audio from a presentation that Rob Sherwood did for the Sutton and Cheam Amateur Radio Society on the 18th of June 2020. This is a great presentation. Rob talks about performance, your radio performance, and highlights that probably our biggest problem and biggest area that needs looking at is transmitter performance, certainly at VHF and UHF. I think this is a great feature, and once again, Rob has been very kind to let us reproduce this. The questions at the end are the views of the individuals, and therefore we've let them run through without any problems. Hopefully it won't upset anybody, but the questions are the views of the individuals and not necessarily the ICQ. So without further ado, let's have a listen to what Rob has to say.
So I am now recording tonight's session, and this may be used, I think Martin wants to use it as part of the ICQ podcast on the next episode, so just so you're aware as we go through tonight's session. Hope everyone's fit and well throughout lockdown. Looks like things are starting to ease off now, which is good, so hopefully things can get back to normal soon. But for the time being, we're going to use Zoom. This is our second Zoom session. The technology worked pretty well last time, so I think we're quite pleased. So hopefully, fingers crossed tonight, everything will work okay. We've got 51 people on the call tonight, which is great. Nice turnout. Thank you all for joining. We've got a limit of 100 people, so 51 is okay. If we get to 101, we've got a problem. So hopefully hopefully we're okay with our license with Zoom. I'm going to pass over to Martin for a second, just in case you got any thoughts, Martin, our chairman.
No, I'm extremely pleased that we're using new technology. We're bringing lots of amateurs together in lots of clubs. Prior to technology like this, we wouldn't have been able to ask Rob to join us. I know Rob's on a much different time scale to us. but it's probably middle of the afternoon for Rob and early evening for us. But this is certainly a tool that I think, as we go forward, we should seriously consider doing this sort of thing, because it does bring a lot of people together to actually be able to listen to some of the people that we've heard so much about. And in fairness, I spoke to Rob on Tuesday night. A really nice gentleman. So I'm going to make him embarrassed, but a really nice gentleman. And as I say, please enjoy tonight. It's good. It's good. So back to you, Chris.
Sure. So for those that don't know or not heard of Rob Sherwood is from Sherwood Engineering, very well respected, very well known member of the radio community, very famous for his Sherwood reports. It's the definitive guide to go to if you want to understand about receiver performance. And well, I mean, need to say no more. Rob, I'll pass it over to you. Thank you very much.
All right, very good. So I'm going to pop up my first slide and say welcome to everyone. Thank you for showing up, and enjoyed the chance to give a presentation across the pond. It's 1 o'clock here in Denver, Colorado. So I'm going to talk about performance, not only HF, which has been sort of typical over the last 40 years, but clear up through UHF, and not just receiver performance, but transmitters, which is really now an issue, and I will get into that. So next slide. So we don't want to just focus on a few transceivers. I started testing receivers in 1976. Of course, that was before the internet, so it was just published on paper. And we've just got amazing choices today on the HF range up through 6 meters, but not so many choices on VHF and UHF. And there's some new challenges, so let's take a look. Next slide. I get asked to sort my web table. It's sorted by close-in dynamic range, and I'll explain that. But some people say, well, why don't you sort it by sensitivity? And it's really not an issue. And so here's 3 examples of sensitivity of receivers. The R390A, probably you've heard of that, goes clear back to 1954, and the sensitivity was 0.2 microvolts. Well, the R4C that I kind of became famous for, because I made kits for that since the 70s, 0.2 microvolts. And then if you take a K3S with preamp number 1 turned on, 0.2 microvolts. So sensitivity is not an issue. But what is an issue, and it's getting worse by the decade, is urban noise, RFI. Next. So we had sensitivity clear back to years and years ago in the 40s and 50s. It was always listed in microvolts. So I still do that just for historic purposes if you want to compare your older radio to something today. So it's on my website that way. The sensitivity was a sideband measurement with a 10 dB signal plus noise to noise ratio. It could be a 2.4, 2.1, whatever the standard filter was. And just quickly how you measure that, you feed in a signal and you put the signal out of the passband and you turn the audio up so it's reading, let's say, a reference level on an analog voltmeter, and hopefully it's got a dB scale, makes it easier, and you set it for like -10, and then you tune the signal in, a single carrier, and you want that audio meter to go up 10 dB. So that's the way we measure sensitivity. But then in 1975, noise floor and dynamic range came out as terms that were new to us. And noise floor was standardized on a CW bandwidth. We can measure it for any bandwidth, but it was 500 hertz. Most rigs had a 500 hertz filter, or at least as an option. But that's a 3 dB signal plus noise to noise ratio. So when you tune in this test signal, the audio meter goes up 3 dB. And by definition, if it goes up 3 dB, that's the same level as the noise, because the two add up. And there's the noise floor measurements for the same 3 rigs, receivers. You see they're about the same from each other. Next. So really reception today in an urban environment is pretty much local noise limited. I would say I moved to Denver in 1969, and between 69 and 2019, I would say urban noise has gone up about 3 dB per decade. It could be worse in some cases. And what are these sources of noise that are causing us problems? Well, I don't know what it's like in the UK, but in Denver, line noise has gotten a lot worse. It's as though the power company doesn't take care of their insulators very well. So that's a problem. Wall warts, well, things that get charged up like iPhones. In the old days, things that got charged just had a transformer and a couple diodes, but everything today has a switching power supply in it that's a wall wart, and that makes a bunch of noise. One of my friends up in Boulder, Colorado, has just been doing a search and destroy on all the noise sources in his house. Of course, computers all have switching power supplies. Our household appliances, they've got microprocessors in them, your refrigerator, your dishwasher, your washing machine. That puts out racket. In my case, out in the country, I have some towers that are 200 feet from the house and some that are closer to the house, and believe me, it makes the difference if you can get your antenna away from the house. Light dimmers, LED bulbs, and all that, lots of things make noise. We've got problems with grow lights. That means people growing pot in their basement, and they make terrible noise. Sometimes 10-block radius would be wiped out. So lots of sources of noise today, unfortunately. Next. Okay, so the other main performance, of course, I've been talking about now for decades is dynamic range. And it's sort of become the search for the magic 100 dB radio. Nothing magic about 100 dB. It's a nice round number, and certainly it's a great number. And it's not hard to buy today. Probably don't need 100 dB, but we have that kind of technology today, at least up through 6 meters. Not so much above that, up on 2 meters and 70 centimeters. Oops, I think we skipped one. So what is really the meaning of dynamic range? Why do we care? So we want to work the strong. No, let's try again. We want to work the weak signals, and we're surrounded by strong signals. So the receiver needs to handle multiple signals at once and hopefully not generate interference of its own. So we're trying to work that weak multiplier for a contest, or the number 100 for DXCC, or whatever it is, and we've got all these other strong signals around. Ever since the classic radios like a Collins went away, they had a pre-selector and, of course, ham band only, and we got general coverage transceivers. They were synthesized. That was nice. They had digital readouts, but they all went to what we called up conversion, and the first IF was above 6 meters typically. And that had its limits. And in that case, the classic dynamic range test that got defined in 1975 really didn't apply too much anymore. It was fine for a radio designed in, say, 1950 or 1960, began to change in the 70s. And then once we found all these up conversion radios, it was kind of meaningless. So really the only major up conversion radio today that's a current product is the very expensive flagship for ICOM, but otherwise the up conversion radios that were like a Pro 3, for example, okay on sideband, and a compromise on CW and big pileups. So it's the world changed there. We went through a cycle, and that for the VHF and the UHF operator, really the choices are many fewer and mostly up conversion still today, even though the HF world has kind of given up on that. 2 meter performance is still not up to par with what we're used to on even 6 meters. The Flex 6700 does cover 2 meters, but it only puts out as a transmitter plus 7 dBm. So then you need an amplifier, and I have no idea how many people actually do that. I know Beco makes an amp that would work with that. So there we have that. Next slide. So what do these numbers mean? And some of these are receive, some of them are transmit. So we worry about close-in dynamic range for a CW contest, pileup, de-expedition standpoint. And for digital, I would say a RTTY contest is probably the worst for digital. The WSJT stuff is kind of all in the passband, so that's a little bit different. We do need that noise floor measurement, that 3 dB signal plus noise to noise ratio measurement in order to come up with the dynamic range numbers, so we need that. And then once we started having these synthesized radios that we kind of liked for some reasons, that general coverage, digital readout, didn't drift anymore, but phase noise was a problem, and it was really a problem for like 25 years. And in 2012, the league came up with a term. Before that, if you went to my website, and it's still listed this way today, if you've got a footnote that says it's phase noise limited, it happens to be the F footnote in my case, I gave whichever was the worst. If it was the third order intermod product was the limit, then it just said some number, 85 dB or whatever it was. But if it was noise limited by the synthesizer in the radio, then I just put the footnote in there. But now it's defined as reciprocal mixing dynamic range, and I'll show you a little graphic about that in a moment. Transmitted broadband noise, that isn't talked about much, but it's certainly a big deal for field day. If you've got multiple transmitters on the same band, CW, FT8 now probably, and sideband, maybe on 20 meters and 40 meters. If you're all in that same band, your bandpass filters that maybe you've got for 10, 15, 20, whatever, don't do you any good there. Transmitted splatter on sideband really is a performance limitation, so we'll look at that. And then, of course, key clicks on CW. So lots of things are on the transmit side we need to pay attention to. Next.
And Rob, we've got one question so far. If you want to take it now,
Sure.
we're going to wait until the end.
No, go ahead. No, go ahead.
Colin Smithers is asking, why do the VHF and UHF specifications remain so poorly behind HF?
Well, when we look at newer data, like with the new ICOM 9700, we see that as we go up in frequency, the phase noise gets to be a bigger problem. We're definitely an up conversion radio, except for this new direct sampling. So the up conversion radios have a wide front end of like 15 kilohertz typically. And so if there's a bunch of signals in that 15 kc or so bandwidth, this all propagates downstream. So the technology is just beginning to move forward, particularly with this new direct sampling ICOM. So that's kind of where we're stuck with the problem. We can't really, for instance, like a K3, just as an example, when we went back to what we call down conversion radios, you can't make a 500 hertz filter on for a first IF of like 70 megahertz. So that's a physics problem.
Thank you, Rob. Let me move on to the next slide for you. There we go.
Okay, so as I mentioned, 1975, QST published the new definition for us as amateurs, dynamic range, noise floor, and Ham Radio Magazine, which was a wonderful publication, a long missed. So what is this dynamic range all about? So we don't want the receiver to be producing interference of its own. So that's really what we meant by dynamic range. We start feeding in two signals, two equal strength signals, and we keep increasing the level until we get distortion in the radio. So they simply defined it when the distortion of the third order distortion product equals the noise floor. So that difference between those two signal levels are what the dynamic range. And then as you go up, the radio tends to overload kind of in a hurry after that. So as an example of how we do that, let's say we put in two signals. We'd already measured the noise floor, let's say minus 128 dBm, and the two signals that we fed in that produced the third order distortion product equal to the noise floor, let's say it was minus 28, just as an example. Well, there would be our 100 dB radio, because the difference between the noise floor and these two test signals is at 100 dB, or maybe it's 80 dB, or whatever it is. So that's how we came up with the term dynamic range. And back then, that's all they did was a 20 kilohertz test, which I'll explain why that wasn't adequate as time went by. Okay, go ahead. So here's an example of why I started testing radios. This case, it happened to be an R4C. It wasn't an up conversion radio, but it did have a wide roofing filter. And then everybody else's radios that we had for like 25 years that were the up conversion, where the first IF was certainly above 10 meters and usually above 6 meters. And we couldn't have a filter that was really narrow at those frequencies, so they were typically used an FM bandwidth filter 15 or 20 kilohertz wide. So the old-fashioned test that had the signals 20 kilohertz apart that were fine for an S-line or even something older, a national. Well, those two tones were 20 kilohertz down the band or 40 kilohertz away, and they didn't make it through the roofing filter. So it really wasn't testing the radio, it was testing the first mixer. So in the case of the R4C, it was an 8kC filter, but it tested fine. It got good reviews that way, but when you used it in a 160 meter CW contest, it crashed. So I said, well, the radio is what it is. So the test is no good. So I had two rather old-fashioned at the time signal generators from HP. And so I said, okay, let's put the two signals 2 kilohertz apart. In that case, whether it was an up conversion radio with a 15 kC roofing filter or a Drake with an 8 kC, those two signals went through the filter. And then suddenly we were testing way further down the radio, and the numbers plummeted. For instance, in the Drake case, they went from like mid 80s to below 60. So we saw, oops, big problem. So that's how I started testing radios. That's why, because my radio fell apart, and I started testing radios and publishing data back there in the 70s. Next. So we mentioned synthesizers. And why is that a problem? Well, we don't listen to the local oscillator or the clock in a direct sampling radio, but a local oscillator has noise on it. And particularly a long time ago, the synthesizers are really pretty terrible. So let's look at this graphic that I found on the web. That little bullet-nosed signal on the left, that's the weak guy we're trying to work. That's our DXCC number 100. And near it is a really strong signal. And let's make it a perfect signal, which of course doesn't exist, but even if it did, doesn't matter. So what happens is the local oscillator has noise. Every oscillator has noise. But when we were back in the old days with a Collins, let's say, and a PTO and a band crystal, we didn't really have noise troubles. But now we have synthesizer noise, and so it was really a significant problem. So the noise on the local oscillator would mix with that really strong signal and put the side bands on that strong signal, and it would overlap on top of the weak signal. Now this graphic implies that the noise probably falls off fairly quickly, which it may in some rigs. You would hope it would. But for instance, the Flex 5000 or the FTDX 3000, their noise spectra is flat. You can measure it at 10 kilohertz and 100 kilohertz, and it's the same. So for field day, that'd be terrible. So some radios had phase noise close in, and some had phase noise that kind of went on forever. Next. So for many years, and I'd say about 25 years, this phase noise problem often dominated over the classic dynamic range measurement. There were a few that didn't, but if you really would like the reciprocal mixing dynamic range to be a bigger number than the classic third order dynamic range, because all it takes is that one signal that's strong nearby to cause a problem with phase noise. But for a third order product, you have to have at least two, and sometimes if you're in a big pileup, you'd have multiple. So we really would like that number to be bigger than the dynamic range numbers. So that's the case on some. The K3S, if you have a K3 and haven't upgraded your synthesizer, I'd recommend it. The expensive ICOM, the 7851, and then the two newest HF rigs that came out a year ago and 2 years ago. The Yaesu came out last year, the Kenwood 2 years ago, and they've really figured out how to make synthesizers that are clean. All three of those, the Elecraft, the Yaesu, and the Kenwood. And of course the ICOM, but wow, $12,000. But luckily, if we've got a direct sampling radio, we don't have to know how to design a good synthesizer. All we have to do is install a really clean clock oscillator. And so the direct sampling radios from ICOM, Flex, and Apache, they pretty much don't have to worry about reciprocal mixing anymore. Next. So today, what do we have? We've got superhets still. They've been around forever, of course. Direct sampling, and then the hybrids. Now, the hybrid really means that's the new Yaesu and the new Kenwood. It has a direct sampling band scope and a direct sampling waterfall. So it doesn't affect the actual operation as far as working weak signals in the middle of a pileup, but it does give you a good visualization of what's going on in much more detail than the older type of band scopes like the Pro 3 had or something like that. Both of these types, the superhet and the direct sampling, they work. I don't know how many of you people work stations for a WRTC contest last year in Germany, but all the brands were there, the top line radios. So it didn't really, there was no significant difference between which of these two samples you picked. You picked a direct sampling, you picked a superhet, they all work. But I would say in certain cases, when you've got signals very close in, nearby, the superhet has an advantage because it has a roofing filter. Even if it was a 15 kC roofing filter, and of course if it was a Elecraft, for instance, or the new Kenwood or the new Yaesu, you've got a sideband bandwidth roofing filter and a CW bandwidth roofing filter. So that knocks out most of the signals on the band. They don't get past the roofing filter. So you've got about a 30 dB advantage if you have signals that are like more than 60/9. Now, luckily, I don't think most of us have a neighbor that's 60/9, but if we do, we might decide to stay with the superhet. I've gotten emails and phone calls in the last month or two, or two different people called up and said, I need a new rig. I've got a ham moved in 2 blocks away. So I don't envy that. The direct sampling.
Sorry.
Yeah, go ahead.
So I was going to say, I've got another question, that's all.
Sure.
Someone's asking about what's the proper metric for dynamic range in an SDR?
Okay, I'll cover that in a slide coming up and explain what that's all about. We test it the same way, but it's a little more complicated because it's not as consistent and it somewhat varies on the architecture, which I'll explain. So the direct sampling radio is all of the band scopes, or at least we know we're getting that. So next slide. So if we do have another transmitter close by, whether it's 2 blocks away, a mile away, line of sight, field day, we do have this advantage if we have a roofing filter. But the direct sampling, by definition, no roofing filter. Some of the direct sampling radios have a bandpass filter for each ham band only. If you go wide band to tune in the short wave, it switches. But half-octave LC filters became very popular once we got all those up-conversion radios that were general coverage. So for instance, the newer ICOMs, they'll have a half-octave filter. So on 20 meters, they cover from about 11 megahertz to 15 megahertz. And there are a lot of commercial broadcast stations in that range below 20 meters and above 20 meters. So your 7300, for example, will be having to deal with commercial stations that are outside the ham band. With the 7610, it does have a tracking preselector. On 20 meters, it's hardly going to knock anything down within the band. On 40 meters, if you're on the low end of CW, it's probably going to knock down the broadcast stations above 7.2 megahertz by about 10 dB. So that's going to help. But if you were on 7190 and there's a broadcast station on 7205, the tracking preselector and the 7610 wouldn't make any difference. So here's a case where the like a K3, for example, with the crystal roofing filter or the new Kenwood or the new Yaesu, they have an advantage if we've got really big signals that are close by. Next. So now let's look at some of the numbers. What do they mean? And do we need the absolute best number? And maybe the advertiser who today has the top on my list, for example, may say yes. And we certainly don't want to be near the bottom of the list, but I don't believe that you've got to feel like I've got to go buy the latest radio that went up 3 dB more than something that came out 2 years ago. That's just kind of crazy. And whatever you've got, let's optimize it so it works the best way. So I'm going to talk about that to some extent. There's lots of choices today that you should feel perfectly adequate, whether you're a DXer, a contester, and then if you're just a rag chewer. So lots of choices. Next. So what is the state of the art today? Not the absolute highest number, but what can we get from all 6 of our major OEMs? At least up through 6 meters. Now 6 meters might be a little bit less in numbers as 20 meters, but not enough to talk about. So dynamic range, third order dynamic range of 95 dB or better. Reciprocal mixing, the phase noise issue of 110. And so radios with this kind of performance, well, you see all the major OEMs, ICOM, Flex, Elecraft, Kenwood, Yaesu. So everybody's now has tremendous receivers. So if you really are tied to a brand, you can stay with your most favorite brand. Everybody's doing a good job today from that standpoint, at least up through 6 meters. Next. Here's a portion of my website chart, but it's the individual top 18 transceivers. Now, if you look at the chart, it's got over 100 transceivers on it, but there were multiples in some cases. And why is that? Well, for instance, the K3 came out in 2008, then the K3S came out. At one point, I was comparing direct sampling to Super Het, and I tested a Flex 6700 and a K3S on 10 meters. That information is there. The direct sampling radios have more variation from unit to unit, in other words, from each individual ADC chip in your specific radio, than the classic Super Hets had. And there was some variation with the classic Super Hets, but not that much. But there's more with the direct sampling. It's not night and day, but it could be 5 dB, maybe a little bit more in some cases. So these are the top 18 specific transceivers. Don't just count number 1 through number 18. That's not what this list is. So we go down here to the 10-Tech Eagle at 90. That just happened to be my cutoff point, 90 dB. We've got several in the 100 plus or minus a few dB range, clear up to the new Yaesu at 110. So we've got all sorts of choices, price range all over the map. The $7,300, $1,000 in the U.S. anyway, $12,000 for the 7851, and even more for the Huberling. One thing the ICOM 7300 did, it crashed the used market. So if you're in the market for a $500 or $600 radio today, you can find it. I don't know how it is in euros or in pounds, but in the U.S., we can buy radios for $500 or $600. Of the 18 transceivers here in this list, I've run 12 of them in major contests at least once, and sometimes more than once. As far as the sort of proof that an operator doesn't have to have your latest and greatest $3,000 or $4,000 radio, N2IC, he really performs well in the contest. He runs a pair of TS590s. So that's, I think, new is a $1,200 radio today, and you can get them used for $600, $700, $800. So buyer's market. Next. Well, here's the elephant in the room. How's the K4 going to perform? Well, it hasn't shipped yet, as you know, and I doubt that Elecraft ever envisioned that a year after Dayton last year, they still hadn't shipped any. This is really probably Titan's cash flow, shall we say. So we don't know how it's going to test. We can make a guess, but we do know the architecture, and I've confirmed this with Wayne. So the basic K4, which will probably ship first, is like a 7610. It's going to be direct sampling. It'll have 2 receivers, and it'll have a nice big LCD screen and a nice display. But if you want the extra performance that like a K3S has, because it has a roofing filter and it doesn't have to look at a big swath of the band, then you have to buy the Super Het module with the roofing filters. Now let me touch on the roofing filters. Of course, as you may know, if you had a K3 with 1 receiver, you could put 5 roofing filters in it. And if you had a second receiver, you could put another 5. I always thought that was crazy. Who needs 10 roofing filters? So the K4 HD will have 4 roofing filters, 2 for the main receiver and 2 for the sub receiver. 1 will be a sideband bandwidth and 1 will be a CW bandwidth. So 4 is plenty. So the architecture of the K4 HD will be like the Yaesu FTDX 101D or the 101MP. So we can kind of make a guess. I mean, since the average direct sampling radio today is about 100 dB, plus or minus like 3 or 4, you would kind of expect the K4 to be similar. And the HD, you would assume it ought to be similar to a K3S. So that'll be our guess. Next. So now, how are we going to make our radio play in an optimum way? And what I'm going to call this is net gain. What do we do with our preamp? What do we do with our attenuators? Now, we probably are used to turning our preamp on, hopefully on the bands that make sense. I don't know how many of you turn your attenuator on regularly. I do. So I'll explain why that is. So, but in general, let's say we're on 15 meters or 10 meters and certainly 6. If you're in a quiet location, the preamp makes sense. If you're in an urban environment that's real noisy, maybe you don't find many bands where the preamp helps. And I'll tell you how to test that later. I talk to people on 40 meters at night, and they're running their preamp, assuming they're using their transmit antenna, not some beverage or something. Running a preamp at 40 meters at night is crazy. Next. So we're going to look at a couple of contests here with a screen capture of a band scope. This was the ARRL 10-meter contest, December 2018. And as you can see, quite a few signals, more than 20 kilohertz, no, more than 20 stations in 10 kilohertz. Now, of course, if you've been on 10 meters the last year or the year before, sunspots have been terrible. So working mostly weak CW, but we still had plenty of stations to work. So what do we see on this besides the fact that we've got good people participating? Upper right-hand corner, note, preamp on. Well, that makes sense. It's 10 meters. I'm out in the country. It's quiet. So the preamp helps. Lower right-hand corner, audio peak filter on. I don't really squeeze this down to try to get really tight selectivity, but it reduces noise. So maybe I have it set for 200 hertz or something. So the audio peak filter can just take the edge off of noise. And of course, if you have some noise reduction you like on your radio, use that too. So there's 10 meters, and this happened to be a TS890S. Next. Well, what can the band scope show besides those signals we just saw? Well, maybe we're looking for a hole in the band, a call CQ. Maybe we're working a de-expedition that's split and we can see who's calling where. It also gets to show us QRM, splatter, key clicks that really we wish weren't there. We've got fantastic filters in this new digital age. We can adjust the bandwidth with the turn of a knob. The shape factors are fantastic. But if sideband splatters in our passband or key clicks in our passband, let alone composite noise, transmitted noise, it doesn't go away with our fancy filters. So we can see these type of things on our band scope. Next. So there's a lot of information here, more than I thought when I took the picture. This happens to be a 7610 on 160 meters, December 2018. And you can see here, we got a lot more QRM than we had on 10 meters, over 30 stations in a 10 kilohertz span. Well, what do we see this time? We look over there on the left, I've got the 12 dB attenuator on. If you look in the middle there, I've got the audio peak filter. So I was doing the same thing as far as the audio peak filter on 160 or 10. But let's talk about this attenuator. I think it's not necessarily intuitive why we want to run an attenuator. So there's two reasons. On the lower bands, and particularly like 160, and most people will hopefully have an inverted L or some sort of a vertical because they get better takeoff angle, you get better ground wave and all that. But we can get amazingly strong signals on 80 meters, 160 meters due to ground wave. So we're more in a potential overload situation. But the difference in band noise, typical band noise between 10 meters and 160 meters is over 30 dB. Well, every transceiver is designed to work on 10 meters and now 6 meters. So we've got sensitivity to burn. So the sensitivity we need on 10 meters or 6 meters, we don't need that on 160 meters, since the band noise is like 30 dB stronger in general, at night, for instance. So let's turn the attenuator on to not only reduce the potential of overload, but we really don't want our AGC running on band noise. That's really tiring. If we're tuning between stations on CW, let's say, and there's no station there, we don't want band noise to be as loud as all those signals are trying to work. So I like to set attenuation. It can be with the attenuator or your RF gain control, so that band noise, the AGC threshold is above band noise. Kind of like 6 dB above band noise is kind of a good starting point. So for instance, let's say we were just tuned in between a station and we're on 80 meters or 160 meters, and we punch in our 6 dB attenuator and nothing happens as far as the noise coming out of the speaker. We punch in 12 dB, maybe it goes down a bit. That's a good starting point. I actually ran one contest where I was comparing rigs. Often I run 2 rigs in a contest because I'm going to compare something new to a reference radio, or maybe there's 2 new radios. So I was comparing the TS 990S with the ICOM 7300. Well, the 7300 has one attenuator, period, 20 dB. And so I set the Kenwood for minus 18 dB attenuation. I had the ICOM at 20, and I ran the whole contest that way. I'd never done that before. I'd always used 12. So now I was using 18 or 20, and actually I loved it. The band noise was, from a fatigue standpoint, was almost out of the picture because the AGC threshold was maybe 10 dB above band noise. Now, on occasionally a weak station, I had to turn up the volume. But, 95% of the stations I worked were stronger than that. So that was really a relaxing contest. So what else do we see here? Well, look at the station on the left that says Key Clicks 5X. You can see on the band scope, and you can see on the waterfall how wide that guy is. And over on the right, there's another signal that's like 2 dB weaker, so insignificantly different between the two signals. Look how narrow that station is. Look at the waterfall. It's just nice and narrow the whole time. Again, back on the left, that guy's key clicks are like 5 times as wide as they should be. And if you also look on the left-hand edge of that key click, of that bad signal, a little kind of blip there trying to stick up, maybe that guy is somebody I need to work. So you can see that in the waterfall and in the band scope, exactly. And he's being covered up by the key clicks. So I'd probably have a hard time working him. And there's no excuse for that. And now it's really the OEM's problem by giving us too many choices, including bad ones. So next slide. Now this also applies to sideband. Now we haven't had any improvement really in sideband cleanliness as far as how clean our signals are until Apache came out with Pure Signal. That's written by Warren Pratt, NR0V. He lives in Loveland, Colorado, about 50 miles from me. And so on the right-hand side there, that happens to be an Apache 8000. It's KA0KA, and I was actually talking to him. And then, lo and behold, down the band 14 KCs, another signal pops up, and look how wide he is. His splatter makes his signal 3 times as wide as his main signal. Now, the Pure Signal guy, Tyler, he's a hi-fi sideband guy. I don't buy that. He said his bandwidth over 4 kilohertz. I'd never do that. So if it was me transmitting, I'd be 2.7 kilohertz wide, not 4.6. So we'll squeeze that guy in if it was using a more reasonable bandwidth. But the point is, that signal is straight up and down. Now, right now, pre-distortion, that's what it really is. It's used in the broadcast industry, television, you name it. It's certainly used in cell phones, transmitters. So pre-distortion is only available today from Apache, but Flex has talked about it for like 8 or 9 years. They haven't offered it yet. It's on a list, but I think it's way down on the list. Elecraft says the K4 will have pre-distortion someday. Obviously, right now, they just need to start shipping radios, and the software development, I don't know, maybe it'll take a few years. I have no idea. But they say they'll do it. Why was this not a surprise? All the new amplifiers, solid-state amplifiers that come out in the last few years have a sampling port built in. Now, if you've got an older amplifier like a Heathkit or something, you can put a sampling port on the back of your, on the output side of your Heathkit or your whatever amplifier. But the new Elecraft amp, the KPA 1500, the Hilberling, the SBE amplifiers, all these things have come out in the last few years. They're probably running LDMOS. They've got a sampler output. So right now, you can only put that sampler signal into the Apache. So and of course, the Power Genius from Flex, that's got a sampler port. So maybe Flex will come along and maybe Elecraft will come along. Will the Japanese ever come along? I don't know. Next. So what happens above 6 meters? Everything covers 6 meters today, but when we go above that, things degrade. Almost everything degrades about 10 dB. The dynamic range degrades. The reciprocal mixing dynamic range, the phase noise degrades, and transmit splatter on sideband, auto order distortion degrades. So that's the unfortunate reality. Next. So let's look at a couple examples here. I'm going to look at an older radio that's probably been out for 20 plus years. The Yaesu 736R, which is popular with the VHF and UHF guides, along with the TS2000 or the TX2000X, for example, and the new ICOM 9700. Well, wide space dynamic range, and of course the Yaesu's going to be an up conversion radio with a wide filter in the roofing filter. The new ICOM is either maybe not quite as good or maybe it's a little bit better. But at 2 kilohertz, the new ICOM is definitely a little bit better or a lot better. And I'll explain why the question marks. The phase noise in this case, the reciprocal mixing, about the same. So that's not much of an issue there. So the question is, what's this new rig like? Because we really haven't had any new VHF, UHF rigs of any significance for a long time. Next. So to answer the question about testing dynamic range on direct sampling radios, it isn't that difficult, and it's particularly more simple at HF because all the direct sampling radios either have what's called dither, which linearizes the ADC chip. It's either got built-in dither or the way Flex does it, because their ADC chip does not have built-in dither. They inject a dithering signal that linearizes the ADC chip. So the numbers are not that different, except it doesn't matter which test spacing. If it's a direct sampling radio, we can test it at 20 kilohertz, 2 kilohertz, 100 kilohertz to make any difference. It's all the same, unlike our radios that have a roofing filter. But here, this VHF, UHF direct sampling radio does not have dither. It still has what's called IP+, which at least on the HF versions of the ICOM radios is dither and does linearize the ADC chip. No one knows outside of ICOM what the button does on the 9700, but it doesn't do much. There's 2 graphs of the distortion graph with the dither on and off. So ignore the 2 different lines. They're all virtually the same. So what's this really mean? We can test the radio, and by definition, we keep increasing the 2 signals until the distortion product equals the noise floor. That was the definition from 1975. Well, at the lowest level, when I tested my 9700, I got a dynamic range of about 75. And then if we were testing a classic super het, once we reach that point where the 3rd order distortion is at the noise floor, and we just keep increasing the 2 test signals, the distortion just gets worse and worse and worse at about a 3-to-1 ratio, or at least 2-to-1 ratio. Well, here I started increasing the test signals, and it went up as we'd expected, about 10 dB, but then it went down. And it actually, we have another point where we can, by definition, say the dynamic range is 86 dB because the distortion product equaled the noise floor. And then I increased it some more, and it went up, but then lo and behold, it went down again. So at the minus 41 dBm test level, the dynamic range of the 9700 is 91 dB. If you look at the QST review that I think came out in January of this year, they published 91 dB. So we agree, but did anybody test it at a lower level? Or did they just sort of give the best number? Because everything on my website is worst case. For instance, when we're doing a dynamic range test, we look at the third order product that's below the test signals, and we look at the third order product above the test signals. They're usually similar, but not identical. So I take the worst number, and that's what the league does too. At least they have done in the recent past. They don't necessarily cherry pick the number. So I don't know what happened here. Everybody's chip in their individual transceiver is going to be different, so someone else's may not be exactly like this. So this is my quandary that I'm hoping I'm going to get input from the UK and from the continent as to how is this new ICOM, which is really the only new rig for you guys that are really serious VHF UHFers, how is this rig playing if dynamic range is the limit, which it may not be. It may be sideband splatter. It may be transmitted noise. It may be reciprocal mixing. So I just don't know. But there's the quandary. So when we're, for the most part, if we were looking at testing a direct sampling radio that had dither or the way Flex does it, which is the equivalent, we wouldn't have this funny graph. It would just be more or less a straight line going slightly up to the right. Next. So let's look at what we had for choices over 25 or now 30 years. I owned a 275H. It came out in 1987. Then there was some interim rigs in there, and the IC9100 is a kind of DC light radio, but it covers 2 meters and 70 centimeters. So the older ICOM, the wide space dynamic range was good, 85. It dropped off precipitously at 2 kilohertz into the 60s. And then 25 years later, well, the 9100 was a little better, like 6 dB better, but am I going to buy a new radio to get a 6 dB improvement? Probably not. So we really didn't have much of a change over 25 or now 30 years. Next. So now let's get back to deciding how are we going to operate our rig for best performance. We've talked about adding the attenuator on the low bands for multiple reasons. Reduce overload, set the AGC threshold above band noise. But on the upper bands, when do we need it? Or you could just say, I'm going to turn it on all the time, but that's really not the way to do it. So we've got data here on 10 meters, 6 meters, and 2 meters. They happen to be both ICOMs, a Pro 3 and the new 9700. The antennas in all cases were 4 or 5 element monobanders at 50 to 75 feet in the air. So what's significant here? Antenna noise gain means how much does the noise go up when your antenna connects. So to do this right, we'd really like to have a dummy load accessible. So maybe you put a dummy load on an RX port, or maybe you don't really use your second antenna input, or maybe you just got an alpha delta antenna switch and you put a dummy load on one of the positions. So that's really handy. So if we go to the dummy load, and then in this case, of course, I've got a meter on the speaker output, but you can kind of do this by ear. So we listen to the noise coming out of the radio with the dummy load, and then we switch to our antenna, tuned between stations, of course. And if the band noise on 10 meters here goes up 3 dB, what does that mean? That means the radio is contributing half the noise, and band noise is half the noise. Well, we don't really want the radio to be contributing half the noise. So in 10 meters, if I turn on preamp 1, the band noise increases almost 10 dB. Anything between 8 and 10 dB is fine. So in this case, band noise totally dominates and the receiver noise is virtually insignificant if we have preamp 1 on 10 meters. But if we go to 6 meters, and I've never used a transceiver yet on 6 meters with the preamp off where I could really hear the antenna connect. They all needed a preamp, and that's not a surprise if you're in a quiet location. So in this case, preamp 1 didn't do it. We had to go to preamp 2, and then we're almost 10 dB again. So we're in great shape. Now, I'm not in such great shape on 2 meters. I mean, I like my little radio, it's great, but my 2-meter antenna is on my 15-meter tower. I mean, my tower that has my 15-meter Yagi on it, and it has 270 feet of half-inch hardline, plus some coax pigtails on each end, for the rotator on the top of the tower and to run in the house. I don't want to run the hardline in the house. So I only get an antenna noise gain pointed north of a half a dB. Well, I can measure that. You can't even hear it. If I point towards Greeley, which is a city about 20 miles from me, it goes up about 4 dB. Well, that's really not adequate, but that's just urban noise I'm picking up. So if I am trying to work something like Cheyenne, Wyoming, which that's actually fairly easy, it's only about 40 miles away, and they're at 1,000-foot higher elevation than I am, so I don't have any problem working Cheyenne on 2-meter sideband. But I don't have enough antenna noise gain. So there, if I'm on 2 meters or 70 centimeters, if I'm really efficient audio, I really need a mass-mounted preamp, or I need a whole lot shorter feed line. Next. Okay, so now we're just going to be talking about what's happening for the VHF contesters and DXers. We just had a ARRL VHF contest this past weekend, 6 meters, 2 meters, 70 centimeters. So what do you mostly run? I like feedback from you guys. And if you can email it to me, rob@nc0b.com, rob@nc0b.com. You work sideband, CW digital. Maybe it's FT8, maybe it's JT65. But while transmit IMD splatter isn't particularly good on HF, it's worse on UHF and VHF. On HF, most of the rigs are about 35 dB below PEP. I don't like the PEP method, and I'll show you why in a moment, but that's a feel-good measurement. It's really minus 29 dBc. I'll explain that, but so we'll go with the advertisements. The advertisements use PEP. The QST reviews use use PEP. I assume RSDB also does. But by the time we get to 2 meters, we're about 10 dB worse on transmitted splatter. If we look up in our archives on the ARRL data on the ICOM 275, the 910, and the 9100, it's minus 26, plus or minus 1. So didn't get better, didn't get worse, but it's 10 dB worse than what we expect on HF. But we don't measure PEP really with a spectrum analyzer. So if we have a minus 26 dB PEP on a measurement, it's really minus 20. So let's look at the next slide and we'll start getting an idea what this is all about. Well, here's some examples of other rigs, and look at those 3 that I've highlighted in red. Instead of being minus 26 or an HF minus 30 or better, minus 35, whatever, we're something in the teens, minus 14 dBc, minus 16, minus 18. That's just terrible. So add to that the fact that a lot of people use what I call a brick amplifier on 2 meters and maybe 70 centimeters. That's really meant for FM. When I'm on my 8 o'clock a.m. beam spinners net on 2 meters, some of the stations are nice and strong, 10 over 9, but they're like 18 kilohertz wide on my little 9700 display. And so I worked with one of the guys, said, well, turn that brick amp off. And he went from being like 16 or 18 kilohertz wide down to about 8 kilohertz wide. And he was strong, so I could see his splatter even when he's turning his amplifier off. So what your amplifier is really an issue. And for instance, if you had that flex that put out -7 or +7 dBm, you're going to need an amplifier, so you're going to have to really pay attention in that case. What's your amplifier? Next. So here's our spectrum analyzer. Here's how I measure odd order distortion on transmit. This is the cleanest transmitter I've ever owned. It's a Collins 32S3. This was 20 meters and 100 watts. I think it's out of production. At least I can buy one on the used market, I guess. But you can look at this. You see I'm measuring it with 2 cursors. I put 1 cursor dot on one of those 2 tones. They're equal tones. And I put the other cursor dot on whichever odd order product I'm trying to measure. It's set on 3rd order now, 3rd, 5th, 7th, 9th. I can measure them. And it just comes out a readout right there, 36.5, -36.5. So the 3rd order number is good, but really more important is how fast do those high order, odd order distortion products fall away. So this is plus or minus 20 kilohertz span, plus or minus 20. And pretty much we're looking at an 80 dB range there, but pretty much everything's gone plus or minus 10. So that's pretty good. That's the best transmitter I've ever owned. Next. Now this is a TS990. It's got a 50 volt PA, and I'd say in general, the 50 volt PAs can be about a 5 or 6 dB better than the 13 volt PAs. Well, in this case, the 3rd order measured there with the 2 cursors is -34. So that was 2.5 dB worse than the Collins. But look, now those distortion products go out really about plus or minus 9 kilohertz, plus or minus 18 kilohertz. Instead of plus or minus 10, it's about plus or minus 18. So they don't fall off nearly as quickly. Next. Here's a K3, and that's actually using the built-in test signal. Well, this one is about 10 dB worse than the Collins, but more significant, look at the pattern. We're going plus or minus 20, and it hasn't even run off the scale on the vertical scale yet. We measure with these 2 cursors dBc. dB, it means dB below the carrier. Well, the carrier in this case is our 2 test signals. To get the PEP number, you add 6 dB to that if you like a bigger number, but it doesn't affect what's going on. But what's the significance of this? I've said that your dynamic range needs to be much better for CW or RIDI contests or things like that, because the signals are narrower and we don't have this problem. Here we're 4 kilohertz away. Look at the vertical arrow. We're 4 kilohertz away from the signal, and the distortion products are 45 dB down. Well, if this was a TS590 with a 92 dB dynamic range, well, its dynamic range is way better than the 45 dB splatter. And really, if we looked at the continuum of the upconversion radios that we had for about 20 or 25 years, the average dynamic range close in was 70 dB, plus or minus 5. And so if it's a 70 dB radio and the splatter is down 45 dB, again, the radio is not the limit. Where on CW, it might have been the limit, or in a RIDI contest, it might have been the limit. But in sideband, it's usually the transmitted splatter. Next. Speaking of transmitted splatter, if you operate any contest recently, WPX or the RLDX, I've spent time on 15 meters. I didn't want to really battle it out. And there's some signals on the air that are just plain terrible. So the rigs aren't that terrible. They may not be as good as we'd like, but they're not that terrible. So are you overdriving your amplifier? Are you monitoring? I run a scope 100% of the time. So really, you need to pay attention. I don't know how in the old days when I didn't know anything and I had a 3500Z, I have no idea if I was overdriving it. And then, of course, these brick amplifiers I was complaining about on 2 meters, they're just terrible. So how does CW compare? Do you have the same type of problem trying to work close in to a strong station when you're trying to work that weak station? And it may come down to a menu in your computer. I'm sorry, a menu in your transceiver. Next. Okay, this is a CW transmission. It's a TS890S sending DITs at 30 words a minute. The speed doesn't really matter, but you can go into a menu in the rig and adjust the rise time. And you're given choices that are terrible and a choice that's okay and in between. Look at this graphic here. You would hope that you could work a weak signal 1 kc away from a strong CW signal. I mean, if the guy just had a rock on the key, his signal would be about, whatever, 200 hertz wide or something, or 100 hertz wide. But once we're keying it, then we've got key clicks. And the difference in key clicks between the menu setting of 1 millisecond or 6 milliseconds is 25 dB. 25 dB worse key clicks by picking the wrong rise time. I don't think the OEM should let you even do that. Elecraft does not. They set it at, I think, 5 milliseconds. You can't mess with it, and you're not going to be able to mess with it with the K4. But I think I'm sure every radio I own, I can go in and pick ridiculous 1 millisecond rise time. It should flash up on the screen, turn on terrible key clicks, be a terrible neighbor, bother your fellow operators. I'm waiting for that thing to flash up. Okay, next slide. This is what rise time looks like on a time domain. And on the left, that's a 3 millisecond rise time, not even 1. This happened to be a 10-tech rig. So from 3 to 10, you can see the big difference. So when you don't ramp up quite so quickly, you don't have so many key clicks. So that's what it looks like in the time domain. Transmit composite noise doesn't get a lot of press. I don't know how many of you read my QST article, December of last year, and I talked about the fact that it's time to clean up our transmitters, and that can be sideband splatter, that can be transmitted phase noise, and key clicks, of course. So let's sort of compare our VHF, UHF rigs to HF rigs. Well, here's the 9700. We're talking about noise that's going to be a problem for field day for sure if you've got more than one station on a given band, or maybe you're bothering another field day station that's a mile away, whatever. Well, it's okay on 2 meters. I mean, there's certainly many things worse, but so it's minus 121 at 10 kilohertz, and it gets better at 100, see? But on 70 centimeters, it's basically 10 dB worse. So every time you go up in frequency, it gets worse. Whether most of the measurements are made on 20, 6 meter measurements are a little bit worse, 2 meter measurements are worse still, and then 70 centimeters, like I say, 10 dB worse. Now let's compare it to HF, because this isn't probably something you look at all day, like crazy people like me. So look at the 7610 on 20 meters. It's minus 128 at 10 kilohertz, so that's better than 2 meters. And it's really good at 100 kilohertz. And the K3S is almost as good at 10 as it is at 100, so it's kind of one of the best ones. But look over here at the Yaesu FTDX 3000. At 10 kilohertz, it's 120. Well, that's about the same as up on 2 meters. So it ought to be better on 20 meters than 2 meters. And then look at it at 100 kilohertz. It didn't get better. It's like 1 dB different. So if you're trying to do field day with an FTDX 3000 and you've got a CW station and a sideband station on 40 meters or 20 meters, that's a noise generator. So that's just awful. Switch. Okay, wrapping it up here. If we look at our past data in QST or RSGB for all these rigs that have been now in the market for 10, 20, 30 years, there's not really as much data as there is in our HF stuff now. There was 20 kilohertz data, maybe 5 kilohertz data for dynamic range. There was probably a transmit IMD data, which wasn't very good. But for the most part on sideband, splatter dominates for signals that are 5 or 10 kilohertz away. If they're really strong, we're trying to work that weak one. And of course, it degrades, as I showed, as we go up in frequency. Really, VHF and UHF rigs have been stagnant. As that one example, we went for 25 years and saw a 6 dB improvement. That's not much. And I think there were some interim rigs there that had terrible transmit phase noise, so I've been told. The new ICOM is interesting. It's not the ultimate rig. We could say, well, we want better this, that, and the other, but at least we have a new rig with new technology, new architecture, and maybe that'll then, some of the other competing OEMs will say, well, what am I going to bring out? I understand that the TS2000 has been discontinued by Kenwood, so they've got a big hole in their product line. They right now have the TS890, of course they've still got the 990, they've got the 590, but they don't have a $2,000 radio, and they don't have a VHF radio. So maybe there's an option, there's an opportunity there for Kenwood. The FT736R has been around forever also, so maybe some competition will get everyone off the duff. So I need input from you guys as to what really happens in the UK and on the continent for a serious VHF and UHFers, particularly in contests, is what's really causing you problems. Next slide. Well, upconversion radios have basically gone away at HF, not so much at VHF. Would still pretty much, except for the new ICOM, they're still upconversion radios, and that's going to have issues. What about transverters? I'm sure on receives, transverters probably have an advantage, but then you've got to transmit. So if you've got a transverter that puts out, plus 10 dBm, and you stick some brick amplifier on it, well, that's not going to be too good. So what are the people who do go to the trouble to have transverters? Is everybody else's signal crappy? And maybe even your signal is crappy if you've got a brick amplifier. So I need to get feedback. I don't read enough about that. I was not able to give an on-air analysis of the 9700 in this past ARRL contest, because what do we do in Denver or Colorado on the eastern slope? We just get on 144.2 and everybody shows up and we work them everybody one at a time, round robin, and we don't spread out over 10, 20, 30 kilohertz and have to deal with adjacent signals. We just get on one frequency, and that didn't prove anything. So that's where I'm really looking for input. Next. So is the transverter still king, at least on receive? I'd like to know that. What are you guys using for amplifiers on VHF and UHF? I mean, some of you could be running tubes. If you read my QST article, tube amplifiers at HF are about 10 or 20 dB cleaner than our current solid state, even including the LDMOS. So what are we doing up on 2 meters and 70 centimeters? My guess is, and I'd certainly like to know that for sure, is adjacent channel splatter is probably a limit. Composite transmitted noise is probably a problem. I don't know how much CW there is. I know FTA, well, WSJT in general is kind of knocked, at least on 6 meters, you don't see much CW anymore. So it's all kind of digital. Input to me, appreciate it. Rob at NC0B.com. I'd like input, and of course today. So take it away. I think that's the last slide, except for a flashlight.
Look. Yep. That's
okay.
The last slide. Thank you, Rob. We've got a couple of folks that may be able to give us some of that input. We've got. I've now set it so people can now unmute themselves. We have. I think we've got G4PIQ. I think it's Andy on the. Andy, do you have some comments for Rob there?
Yes, I do. Can you hear me all right?
Yeah.
Yes.
Super. Thank you. So I've got several microphones connected. I was hoped I unmuted the right one. So firstly, thank you very much to the Sutton and Sheen folks for setting this up. I'm not a member of the club, but I run the VHF contest committee over here. So I see sort of quite a lot of things. I think, firstly, my observation was, really interesting. I think, VHF activity across Europe, there are areas of tremendously high activity. So in our big contests, the biggest stations, it's probably best I talk about Europe rather than the UK. So some of the biggest stations in Europe, you'll see 4, 5, 6, 7, 8 different antenna systems pointing in different directions, each with, anything between, sort of 750 watts and 2 kilowatts into them. Up on top of mountaintops, really well sighted. typically, we used to be a world of lots and lots of valve PAs. There's a lot of LDMOS out there now, typically 1 or 2 sort of 1500 watt class devices. All the big guys are using HF rigs and transverters, and often very high performance transverters like the Kuhn and SSB Electronics ones. You've even got folks who almost combine themselves to a very narrow frequency and have a lattice crystal filter in front of their front end to try and protect themselves from adjacent neighbors on the hilltops. I think probably what really drives receive performance, and probably I think the biggest pain point that we see for receive performance is typically where you've got one big signal in a direction who's close to you, and they can be really loud. So I used to operate with another contest station due east of me, and east is the direction into mainland Europe from where I am. So I had 4 Yagis, so 20-ish dBd of antenna gain. They had 4 Yagis, and UK limits 400 watts. So if you pointed at each other, that's about 0 dBm into the front end of the receiver, and that's pretty tough. And we couldn't survive pointing at each other, but you wanted to be able to survive so you could when you were pointing into the back of each other. And really that meant that dynamic range wasn't the big issue, third order dynamic range, because you were probably limited by the transmit IMD from the other station. So you had to be quite a long way on the band. But what was really important, composite transmit noise, phase noise in the receiver, and blocking dynamic range, because actually the point that you go far enough in the band that you didn't have big receive generated intermods. You were far enough away that your composite transmit noise and your reciprocal mixing got you down in the noise, and you got out of the transmit IMD, and really you just got to the point that your receiver would collapse in gain compression from blocking. So it really felt like that was the important parameter for really big contesting. In terms of the 9700 and what we see as a committee, we there's a lot of them out there. Folks who are not using them in challenging situations find they're very happy with them, but we do get odd things where people expect them to do magic, and we have complaints about the station X is splattering, and actually it's quite clear it's in the receive chain. And also people seeing out of band problems. So when they're operating up on top of mountaintop sites with lots of other transmitters in the vicinity, they're seeing out of band signals coming in as well and driving the rig into saturation. And people also not aware of when the overload light is flashing on the thing that there's big trouble. So that's a bit of feedback from me. I don't know if that's helpful.
Oh, certainly, right. And I guess not a surprise. I would think that splatter and transmit noise, and I'm a little surprised at blocking, though. Blocking numbers, at least on the HF, which you're using with a transverter, is typically 30 dB above the third order dynamic range number.
Yeah. Yes,
So,
and I'd agree. And I think the point I was making about blocking is actually, you typically see environments where you're well beyond the spurious free dynamic range, and actually, if you get your 2 stations far enough separated in the band, you get to the point that the limiting factor of being able to survive on the band is actually set by the blocking dynamic range of the receiver.
okay. I assume you're seeing LD MOS at VHF that's significantly worse than valves. I mean, certainly that's the way it is at HF for sure.
Yeah, I think that's certainly the case. It was definitely happier with the valve PAs, but there's an awful lot of LD MOS out there now, and I think it's one of those things that we're not going to be able to stop. Just hope people will not drive them into saturation.
Well, if we ever get pre-distortion on VHF and UHF, I mean, certainly the cell phone industry lives and dies by pre-distortion. So this can be done if we can get that in the loop.
Yeah, I think what would be interesting about pre-distortion be your views, because again, I think my understanding was pre-distortion, that'll help essentially inside the control loop, so sort of within 10 or 20 kilohertz of the carrier, but I wasn't sure whether it worked well for suppressing really high order intermod products on a signal.
that's true. And when I first saw pre-distortion / pure signal 2 or 3 years ago, within a 40 kilohertz span, like I did those spectrum analyzer plots, it definitely knocked it down about 20 dB, and then it came back up. Now, more recently, that's improved, but you're right. There have been discussions with some of my broadcast friends. I used to be in commercial broadcasting and still have friends that maybe just retired from Harris, which produces TV transmitters. And they were talking to Warren, writes the Apache software, and he was encouraging looking at a wider bandwidth because, just as you said, because it can make it worse at some point if we aren't if we're outside that loop bandwidth.
Yeah, and I think that'll be the interesting thing, because again, when you're mountaintop and you're 120 dB over the noise with someone, actually you need to make sure that your really high order products don't start bubbling back up.
Right. Agreed. Yeah. Thank you.
Okay. Thank you.
Thank you, Andy. Anybody else wanting to make any comments on a kind of similar subject around VHF, UHF?
Yeah, if I could.
Sure. Yeah.
Alvin Seeds G8DOH, so similar contesting background on VHF and UHF. The biggest limitation that we see is other stations' radiated noise. The radiated noise performance of, the typical VHF, UHF transceiver is just unacceptable in a crowded place like Europe if you ever connect a PA to it. As for the linearity of LDMOS, the way a lot of big stations get round it is you simply get a very, very big LDMOS amplifier and drive it gently. And that's it. It saves an awful lot of pain. So in designing our systems, I have just worked out what level I can drive at to keep the signal clean, and it basically means I need an amplifier that's rated for 4 to 6 times the power we're actually going to run, and that it's expensive, but if you haven't got pre-distortion, that's a solution.
Oh, I agree, and I got to measure the Bico 2-meter amp that you can drive with a 6700. This is the 1 kilowatt version and not the 2 kilowatt version. And the fascinating thing to me was it said it was rated for a kilowatt on CW or sideband. It also said the 1 dB compression point was 1050 watts. Well, that's just absurd. So I found, since it was meant for it was the model that had the pre-driver in it, so I could drive it with 2 signal generators through a combiner. If I drove the nominal 1 kilowatt Bico to 400 watts PEP, it was very clean. I guess that's relative, but I would have been very happy running that at 400 watts.
Yeah.
500 watts, okay, I guess. 600 watts, forget it. So in the case if you're limited to 400 watts in the UK, if you buy the 2 kilowatt version and run it at 400 watts, that's the way to do it, I guess.
Yeah, it's expensive, but it's a solution. The other thing, on the IC9700, I was really pleased to see your graph where you measured the actual dynamic range. So far as I'm concerned, it's a 75 dB dynamic range maximum, and it's about time that reviews, you wouldn't professionally ever say that rig was 91 dBs. It's not. This A to D imperfection, what I notice, I have one used as a remote station at a good site, and basically all strong signals seem to be nasty, splattery signals. And I also have a system with a transverter and a K3S. Signal is perfectly beautiful on that. Switch to the 9700 and it sounds like a splattery signal. I think it's difficult. Reviews are published in magazines, and the magazines would not exist without the adverts, but there just doesn't seem to be much market pressure to produce good VHF, UHF transceivers as yet.
Right. Well, I'm not at all surprised by that comment. And like I mentioned, I publish worst case. So if you go to my website, it'll say 75 dB or 76, whatever it said. And there's this controversy. Well, I'll use the term controversy. Many people for years have said the magazines bend over backwards to make the advertisers happy. We get an official statement that's not true. I'm not going to get into the argument who's right, but there has to be pressure. Now, when I wrote for Passport to World Band Radio, I don't know if you people are familiar with that or not. Larry Magny published it for 25 years, and I did all the lab testing. And every review had what he called pros and cons. There were advertisers in the book that came out once a year. The advertisers supported the publication, but there was no whitewashing. There was no puff pieces in Passport to World Band Radio, but that was the anomaly.
Absolutely. Thank you.
Thank you for the question or the comments on Alwyn. Anybody else got any comments on that particular subject for Rob, or should we go on to questions?
So this is Stuart, G3YSX, and I do a bit of work to do with publications at the RSGB. If we know of excellent reviewers, I will make sure that Elaine, the Radcom editor, gets to know about it. And the information I have is that it's absence of reviewers that is the limiting factor in the quality of the reviews.
Well, I don't, that may well be, but like for instance, with the QST reviews, Bob Allison currently, he does the lab work, but someone else writes up the review. And in general, to me, as just if I take off my tester hat and be just an average reader, or I talk to my friends here locally that are average readers, even very technical engineers, they'll say the reviews often read like a slick, a color advertising publication. And so then the question is, let's just say I wrote a review for RSGB, but what will pass through the editor? If I say the 9700 is a 75 dB radio, not a 91 dB radio, well, we don't really want the publication to go out of business because ICOM says, pooey, I don't like that.
I can honestly say that I have never heard of that conversation going that way. If it does behind the scenes, I have never ever seen it, and I've been on the board for 7 years.
Well, good. That's the way it should be. And see, your main reviewer for RSGB, I'm drawing a blank right now. What's my trouble?
Well, it used to be Peter Hart, but we
Peter, right?
But we don't really have a constant. I think it's hard to find good volunteers to do reviews.
And did Peter do it for all those years just as a service for free, or did he get paid?
I think he got paid by the page.
I mean, it certainly takes a lot of effort to write a review.
Indeed. I don't know what the commercials were.
Right, sure.
I might be able to help, Stuart. It's
I'd forgotten you were on there, Steve, yes.
I'm here and listening, Stuart. Hi, Rob. Steve Thomas, General Manager of the RSGB. And no, we don't adjust the figures according to advertising pressure. We really don't. Sometimes they just happen to be wrong. They got wrong, so it's normally by mistake. But Stuart's absolutely right. We're always looking for people who are skilled at doing reviews in the right way, and we wouldn't edit. The editor wouldn't change that. We have a technical editor, and we have an overarching editor. But no, they wouldn't change numbers like you just suggested.
I don't know if let me correct that. I wouldn't say they would change the numbers, but maybe they don't emphasize things. If you look at Bob Allison's sidebars, that's really where the meat is at times. If you look at a recent review where he said the transmitted noise was the worst we've ever measured, don't use it with an amplifier, it has bad key clicks, and et cetera, et cetera. I think that was a little rig out of China. And so the lab numbers were fine, and Bob's comments were excellent, but then someone else writes the major review and it's more glowing, shall we say. So yeah, I mean, it's a problem.
No, I understand completely. But what I was talking to Stuart about just only the other day was having a few more other experience in the VHF space, for instance, having a few more experienced people actually proofread the reviews that are done before they actually go to press. So I think that might be the way forward. So you have somebody that reviews it and you have some other people to proof it. And I think that will help that sort of situation.
But if you know of good reviewers, we're more than willing to listen.
Absolutely.
And yeah.
Absolutely. Yeah.
Well,
Sorry, I forgot I hadn't got the video on. I could have put the video on. Sorry, Rob, I forgot. I was talking into a black box there for a while.
No problem. Well, now, is anyone on the continent doing reviews? I mean, CQDL exists, but I don't read German. So, do they review products? Does it still exist?
Yeah, I believe so.
No, I don't think I've ever seen one. I've certainly never seen anyone refer to it.
Okay. I mean, obviously, I'd be willing to talk about doing reviews. My problem for VHF, UHFs, I can't give you the type of feedback that I just got today because we're out here with the population of 1 person per square mile. I know I'm exaggerating, but it's just a different world here in Colorado.
Yeah, and that's what we were thinking about, the sort of the peer review or proofreading. Peer review is a better word for it, I think. That sort of thing on some of these reviews would. That's why we think it would be a good way to go.
Let me give you an example that caused a flap a long time ago at QST, and then things have improved. I'm really happy with working with Bob Allison on reviews. Sometimes he'll send me one ahead of time, just kind of look it over, and another set of eyes is always good. Well, there was a review when the ICOM 7800 came out, so we're talking about approaching 20 years ago. And the reviewer said he unhooked, I think it was a TS 930, put it on the floor, hooked up the new ICOM radio, and said, I'm hearing signals I think I would not have heard if I'd been listening on my other radio. But he didn't hook both radios up at the same time with an antenna switch. He just said, I think I wouldn't have copied it on the older radio, but the newer one, I can hear the signal. Well, that's nonsense.
Yeah.
So you wonder how that kind of stuff gets through editing.
So, Rob, should Steve, you and I and Elaine have an offline conversation? I'm sure that people want to ask other questions and see if we can do something.
Yeah, I think it'd be a really good idea, Stu, if Rob's up for it.
Actually, could we do that? Set up another time in a week or whenever. I've got another presentation I have to give that I'm virtually late for. So let's do it. And but if we have some other questions, let's talk
go
about
ahead with any of the questions, guys. Now's your time to talk to.
I've got one,
go ahead, Steve.
Yeah, just put the video on. Can't see me very well. Yeah, hi Rob. This is Steve G3ZPS. I posted the question in the sidebar. It seems madness that the big OEM manufacturers still don't offer any sort of pure signal option on their transceivers. It would clean up SSB on our bands. It would start very quickly to clean things up. I had this discussion at Friedrichshafen in the bar of the hotel last year, but due to the German beer, I can't remember who I had the discussion with. But why is it that there's no software updates to take the sampling outputs of amps and feed them back into these Yaesus and all these the new big rigs?
Well, it'd be interesting really to get Warren on here, and you might even want to have Warren give a presentation to you guys at some point in the future. But it really comes down to processing power, and it's going to be fascinating to see what Elecraft is able to pull off. We know that Flex has talked about pre-distortion for, well, at least since the 5000 came out. And Gerald implied that that they could use the second receiver. I don't know if that's how it would work or not. I didn't understand it at the time. It was a new concept. But in that case, you've got a Windows computer or maybe some other operating system, but you've got number crunching in the computer. So we know that Warren can write all that magic in code and run it on the Windows computer. What kind of processing power is in a Yaesu, an ICOM, a Kenwood? Well, it's got an embedded OS, but can it run generic stuff? I don't know.
No.
Eldercraft says they're going to have enough memory space, enough processing power to do it, but that's all what they've said, and they haven't written it yet. Or at least we certainly know it's not going to ship when the K4 first ships, let alone the K4 HD. So I don't know how. I mean, Warren tends to think that it's going to be difficult for, let's say, the big three out of Japan with an embedded OS and a limited processing power and memory space to do something.
Yeah.
So that's the question.
Yeah, it certainly is. It would just help so much.
Oh, it would.
Thanks, Rob.
Sorry, I'm on mute. Thank you, Steve. I think we've got a question from Frank, K4FMH. Over to you, Frank. And for some reason, Frank, I'm not hearing you.
Definitely not muted. Or he is muted, I mean.
Yeah, Frank, we've got a problem with your audio, I'm afraid. Okay, maybe Frank can look at his audio. If anybody else got a question, well, we get Frank to perhaps look at his audio in the meantime.
A question from Colin Smithers.
Go ahead, Colin, and hopefully Frank can sort his audio out while we get your question, if that's okay.
Do you believe that perhaps we should alter or add a parameter to transmit measurement? So not only looking at the third order, but at the slope of the way the products roll off, because it's really a few channels out that it's a problem. And your pictures showed very nicely that a really clean transmitter, the products fall off at a certain slope, and a really bad one, they fall off really in a very shallow fashion. So why don't we talk about that slope as one of the parameters?
Well, I agree, and I think at least in the QST reviews, they'll list third, fourth, fifth, seventh, and ninth. But a graph is nice. I actually like a test what I call band limited white noise.
Yep.
And in some of my other presentations, you might have seen one of that, and it just has a solid curve in effect. One thing that is a problem with the classic two-tone test is often as you approach maximum output on several of the bands, the third order might be equal to or lower than the fifth order. So if you publish the third order, it's nonsense number. If you feed in band limited white noise, you never get a non-monatomic curve. It always falls off smoothly. So whichever you do, to just pay attention to the third order is not adequate, no question, and probably more emphasis should be done on showing at least through the ninth order.
Okay.
Thanks for the question, Colin. Now, Frank, have you managed to figure out your audio?
Okay, can you hear me now?
There
Yes.
we go. We got you. Thank you.
Okay, yes, thanks. Hey, Rob, Frank, K4FMH. Another great presentation, and thank you very much. You're not only a great RF engineer, but I say this as a retired professor, you're an outstanding teacher. So I always learn some stuff from you. A comment about the reviews. Shameless promotion of the ICQ podcast. If you'll listen to both the interview with Bob Allison that I did, as well as Rob Sherwood, you'll get a pretty rich discussion about reviews. And while Bob is not here, I think having been an editor-in-chief for Springer Media in the Netherlands, big scientific publisher, and having published a lot myself, you get a bit of a selection effect in QST. As Bob says, if there's a dog that shows up for review and it's going to get blasted, they really try to talk to the manufacturer to say, you really ought to fix this before we go ahead with it. And most manufacturers would probably want to do that. I may be overstating that just a bit, but I think that's the spirit of at least what Bob Allison had to say there. And there's, and here's my logic. If money bought great reviews in QST, MFJ would have the best products in the world because they buy a lot more advertising than anybody.
I agree. Yeah, well, I agree. And if I gave the wrong impression, I don't want to give that. I mean, the numbers that come out of Bob's lab are great. And you're right. If there is a problem, I think in trying to remember, it doesn't even matter, but there was a rig that came in that had an issue and it went back to the OEM and it took almost a year and then it came back again and they reviewed it. So that's true. But really reviews are very subjective when you're past the numbers. And then we really need users in difficult environments who, like these great comments we got about what really is the problem on VHF, UHF. We really need to be focusing now on the transmit side. That's as we just heard, the transmitted noise, the transmitted splatter, and in HF anyway, key clicks that are just absurd that the operator can turn a knob in his menu and fix. So it's a pleasure to work with Bob, no question. And I think the reviews have. I mean, that one example I gave was from 20 years ago. That was just kind of silly, but I don't think we see that too much anymore either.
Thanks, Frank, for the comment. That's great. Anybody else got any questions while we have Rob on the call here? Okay. This is your last chance, guys. You don't often get to get Rob Sherwood on ask a question. Okay, well, look, Rob, it's been a real privilege to have you on tonight. I'm sure all the guys are really, grateful to have your input, and you've also gone through a fantastic presentation there, and give us some real insights into your world. So I'd like to thank you very much, and I'm sure the rest of the guys on the call tonight would like to thank you for your time and wish you all the best.
Thank you for the invitation. My pleasure.
It's a bit difficult to give applause via Zoom, but you can see people clapping on the little video screens there.
Yeah, I see that. All right. Thank you very much.
Thank you, Rob. And
good night.
Wish you all the best. Thank you.
Bye-bye.
And thank you all the guys for attending tonight. We've had a really good attendance, so thank you very much. And we'll end it there. Thank you.
Thank you for arranging it. Take care. 73.
Cheers, guys. Thanks a lot.
Thanks, Chris.
Thank you.
Thanks, Chris.
Cheers, guys.
The ICQ podcast. Come for a moment. Stay for an hour.
Well, thanks there to Rob Sherwood, November Charlie 0 Bravo, for a very interesting talk there on transmitter performance that he gave to the Sutton and Chin Club that they've kindly allowed us to use in the ICQ podcast. Thank you very much for that. And certainly, Dad, I mean, there was loads of people on that virtual club presentation, and certainly was a success for the way things are going forward, wasn't it?
Yeah, Colin, I must apologise for not recognising you were on the call. Just before we started, as people were coming into the group, and there was like lots of people all over my screen in postage stamp size. I didn't spot you. I apologise. And a few others I didn't spot until after Chris had started the recording. So, yeah, great thing. Originally, we thought it was about 50 odd, but I believe Chris said in the end it ended up about 70 people, and hope everybody got something from it.
Yeah, certainly so. I mean, certainly it was a lot of content in there, so I'm sure they would do. Now, I know you've come across some important information regarding the RSGB convention that's worth sharing with everybody.
Yes, certainly did, Colin. In the nicest possible way. Late last night, the RSGB announced about their convention, and this year, instead of it running over 3 days, this Friday, Saturday and Sunday, they've scaled it back due to obvious reasons. A number of our members are at risk, and you can't have people in the centre staying overnight, and you couldn't do social distancing. So in fairness, they're going to do something, and I believe it's going to be a virtual convention held on the Saturday the 10th of October. So you're going to have to keep your eyes open on how we go forward on that one. I'm hoping it'll all go well for the RSGB on this one. We were booked to be there, and I'm sure that if we're required for this session, we'll do it. However, we normally do a group discussion, and I'm not sure quite how well that would translate to Zoom. What do you think, Colin?
Yeah, it could be the case. I mean, I must admit, I'm rather fed up now with the constant Teams, Zooms, and God knows how many other products are out there that do these virtual meetings. And I've got to be honest, there is nothing like meeting person to person. I know we did it for the reasons we did it, but it certainly is a lot more effective being in front of somebody. So let's find out what that news information is. And of course, that's along with the news earlier on in the show regarding the G-QRP convention as well, does, I suppose, show the positivities that we are keeping events rolling rather than just, say, lose them to COVID and just write off the year. So I suppose it's obviously a positive there. Right, anything else happening in your world before we just need to wrap up and thank a few people, Dad?
Not really. There is an M3 lives just round the corner from me that I've promised I'll go and have a look at his aerial this afternoon. We've been on lockdown, and we're still sort of semi on lockdown. But I had his transceiver in and tested it for him about 6 weeks ago. I'm going to go around with the analyzer and the bird meter and dummy load and see if I can work out what his problem is. It may be water in the coax. It could be anything. I'm trying not to. That your mum and me might be going out later this afternoon, and we're planning to be out and about a bit on Sunday when the podcast is released. So all in all, it's going to be a busy weekend for us before back to work and more of the same.
Is that so? So here's what we're doing: is we're busy. We'll wrap up the show. So important people to thank here. Obviously, we need to thank our donors episode: Gary Bridges, Whiskey Alpha Zero, Victor Mike Victor, and Gary, along with our monthly and annual subscription donors, of course, keeping your show advert free. If you found value in today's show, please feel free to visit us at icqpodcast.com/donate. Where, as I say, anything to send our way as show your value for the show, we'll keep the show advert free for you. Thanks to Rob Sherwood and November Charlie 0 Bravo for his talk on transmitter performance. And thanks as well to Leslie, Golf 0 Charlie India Bravo, Edmund, Mike 0 Mike November Golf, and Dan, Kilo Bravo 6 November Uniform for taking part in the news roundtable with you. If you haven't checked out the video Martin released last week, it's in relation to his Mayflower 2 restoration. It's on our YouTube channel, and you can check it out at youtube.com/ICQ podcast. So that's there for you to check out. And you've had a couple of nice little positive notes on that as well, Dad. So people are certainly enjoying that restoration job you've done there, and it certainly looks very lovely from the video there. So I can't wait to check that in person next time I visit to London. Well, that just about wraps up things. So important thing there, Dad, I'm going to send you off to the kitchen to make Mum a cup of tea and see if you can find her a nice treat to go with it. So I shall let you go off and head off for that.
It's a bit of role reversal today, Colin. Your mum's come in from the kitchen and put a cup of coffee in front of me. So, it could be dangerous, the coffee, but no, it's all fun. I'm going to spend the rest of the day with your mum and thoroughly enjoy the day. So, now your mum's not working, do spend more time with your mum. So, back to you, Colin.
Perfect. Well, let's wrap up the show. We'll say 73 to everybody. And as always, guys, we'll catch you again in a fortnight's time. 73 is all.
Yeah, 73.